So good morning. I'm very excited to welcome you here. My name is Thomas Hartung. I'm the director of the Center for Alternatives to Animal Testing, both in the US and in Europe. I'm very glad we have the opportunity to help with this book launch, which came to us as a present. Normally we have to pay a lot for producing some content, which we can then disseminate here in the center. In this case, when we are in the process of hiring Katrin Herrmann, who will talk in a few minutes, she said, I'm just completing the production of a book. And by the way, wouldn't you be willing to write the afterword or the finalizing chapter of this book? Okay, I come to this back in a second, but I would like first of all to make clear, those of you who have not worked with Kat or not been our guests so far, to tell you a little bit more about our center. I mean, you see here, this is the Bloomberg School of Public Health in the background, 102 years old. Our center is 37 years old. It is the oldest center here in the school, and was the first information hub to be created on alternative methods in the US. And even by European standards, you might guess from my accent that I'm actually European from origin, this was the second center for alternative approaches in the world. So we are pretty active. I had the privilege of leading the center the last 10 years, after Alan Goldberg did lead it for the first 27 years, and established this as really a premier information hub. I like this T-shirt tag to explain what the center is about. It reads, these T-shirts were tested on animals, they didn't fit. And this is what our center is about. Whenever the animal experiment is not fitting really, we are trying to help to promote change towards alternatives. But we are also working on the refinement of those animal experiments which are necessary, in fact, or which are required by law or thought to be necessary, a debate we will have during this day. And Katrin is actually leading exactly this program. For 1 year now, she's heading up our Refinement program, where we are trying to reduce the suffering of animals. And she followed this in this capacity, Joan Solo, who many of you might know because she was for 10 years responsible for the Institute for Laboratory Animal Research at the National Academies, and responsible for keeping the IACUC guidelines up to date. So she's following somebody with a lot of reputation, and we are seeing how she's really trying to help at the moment establish us as a resource for evidence-based refinement. The science behind refinement moving us. This is only a tiny part of our activities. This is our leadership team. In the lower right, you see Katrin, who will be here in a second. We are doing a lot of different things, which I will touch on some in my presentation this afternoon, because I want to use some examples what we are doing to show how paradigm change is actually taking place at this moment. Our center is possible because we are supported. We are supported on the one hand by various industries, and here you see supporters over the last 10 years, both on the US and on the European side. Since 2010 we have a European branch of our center, but 3 times more money comes actually from philanthropy. And this guarantees for us a certain independence, so we can work without being dependent on the industrial financing. But they are for us an important reality check, because together with the regulators and NGOs and academics on our board, they're helping us that we are working for something meaningful, not for scientific papers, but something which is worth implementation. And we're also carrying out competitive research. We are funded by the NIH, the FDA, the Department of Defense, the European Commission. And succeeding with such competitive applications means that we are doing something which is realistic. Because it's very easy to say we will overcome animal testing in 10 years if you don't have to do it yourself. If you are a scientist and you work on just one scientific paper for about 5 years and then try to get somebody recognize it, you understand that science is delivering slower than this. But our center is trying to work on all of these different levels, producing some proof of principle science, stakeholder processes, dissemination of information. We even have policy programs in the EU and in collaboration with Paul Locke here in the US, in Capitol Hill. And if you happen to have a rich uncle or you miss the logo of your company, we always find space for you on this. We're coming together here for the book launch. This is the book. Interestingly, it was supposed to be published on the 29th of March, as you still can read on the website. The bad news is the book is not yet out. And this is one of the, let's say, disappointments which I regularly have with book publishing, and this is one of the reasons why I typically refuse to do any book contributions. The second disappointment is if you see the price of these type of things. This will be $188 once the book is coming out, which should be early, should be early in March 2019. Sorry, I was misled by the publication date. But the good news is it will be a free ebook, and this was possible because of financial support. You will hear more from Katrin about this. The reason why I was willing to do a chapter for this book against my own rules was, first of all, because Katrin is so charming and it's very difficult to say no to her. And you will see this in the future. But the other thing which I found really intriguing, that one of the heroes in the field was doing the foreword, Peter Singer, and I really admire some of his work very much, and so I was flattered to do the last chapter of a book which is introduced by him, and I found this quote which I used in my own chapter. He said here, "I don't think there's much point in bemoaning the state of the world unless there's some way you can think of to improve it. Otherwise, don't bother writing book and go and find a tropical island and lie in the sun." And I think this is what this meeting should be about, that there is actually things we can do. We should not just complain about what is being done. And I hope that we will hear over the day how actual paradigm shift is coming about. Our own work is in toxicology, but it is 90% of all works on alternatives to animal testing, which is actually done in this field. So it is a very interesting area to take as an example, as I will do, as I said in my talk later. We don't have good statistics about animal use in the US, but we have statistics in Europe. And you can see how the 12 million animals are distributed here by various areas, and there is an enormous part academic research is actually contributing to this. What is interesting is that the pharma industry, who is really driven by most pressures for change, is decreasing constantly animal use. Of these stable 12 million, they had 31% in Europe in 2005, and despite increasing their R&D spending, this went down to 19% within only 6 years. This shows that they have understood they need other type of technologies in order to complement and substitute for animal testing. The other thing which I found quite interesting, 80% are rodents, rabbits, and 5% birds, and these are the animals which are excluded from the Animal Welfare Act in the US, so we don't have statistics on their use, and we don't really have full protection for these. They only come in via the NIH funding and IARC guidelines and similar. I would like to stop at this point, just saying our center is trying to combine the humaneness of new approaches with better science, because we believe it is about sound science, it is about serving society with the best possible science, and usually the most humane science is the best science we can do. By this, I would like to hand over to the maître de plaisir, maîtresse de plaisir, Katrin, who is going to lead us through the day. And Katrin, it's your show.
Thank you. Sorry, I have some issues here with the mouse. Yeah, okay. Okay, good morning, everybody. Thank you, Thomas, for your kind introduction, and thank you for having this book launch at, or also it's hosted by CAT, meaning the food is sponsored by CAT and other things. So Thank you for that. I want to go, unfortunately, as you already saw, the book is not out yet. We were really hoping that it would be out by now. We had some production issues, as Thomas already highlighted. The good news is really, yeah, it is expensive, but we got funding from many kind donors, and so it will be available open access. And we are still pushing that it will be earlier than end of March. So what was the idea behind this book? I just want to give a brief overview because we only have 8 authors today, and we are 51 authors in this book. It has 28 chapters, and we have a foreword and an afterword. The goal was to provide an evaluation of the scientific and ethical validity of the persisting and further increasing use of non-human animals in science, and to identify ways to shifting the paradigm towards an animal-free world of science. We had peer reviewers, anonymous peer reviewers, and they gave us great comments also to improve the book, and they also made some nice comments about how good they found the book, that it's actually a good resource also. All the chapters have a lot of references for further reading. And because the book is not out yet, I just wanted to give you a brief overview of the content of the book. And I have some prints here in the front for the table of contents, if you're interested, that you can pick up. So I highlighted in green the authors that will be speaking today. So we started with why and how to shift the paradigm. There's my own chapter where I focused on all the 3 R's and how they are implemented in practice. But I have a focus on refinement, as I'm the director of the refinement program of CAT, and also because it seems to be an area that has gotten a lot of attention in the laboratory animal science world. And then we have another chapter where Lisa Kramer, she will be here this afternoon. She will talk about that, and she will talk about a proposed format for debate, and she also talks about the second chapter they have in the book. And then we have many more chapters, but the authors are not present. But just to give you an idea, part 2 is on politics and legislation of animal experimentation. We have a chapter on political campaigning, for example. We have a chapter from a lawyer, Charlotte Plattner, about how we could rethink the 3 R's. Then we have a chapter about, that's a political critique of animal experimentation by Ariane Ferrari. We have a stakeholder analysis. Then we have also a chapter on thoughts about transparency that comes from 2 colleagues from Australia. And then we have Jim Keen's chapter, who's actually present today and will be the first speaker. Part 4 is about ethics and philosophy. We actually, as you will see, don't have too many chapters on ethics, as we thought it is more convincing to focus on science. Of course, ethics is always important, but it's more science-based. And then the biggest part is part 5 is about the effectiveness of the animal model. In order we first need to assess which areas of animal experimentation might not give us the benefits we are looking for. We have a strong focus in the book on the effectiveness, scrutinizing the effectiveness of the animal model. And there, Lisa Kramer is going to speak about the scientific problems with using non-human animals to predict human response to drugs and disease. We have then several more, and we have a lot of, we have systematic reviews in there. We have also the use of citation analysis. Then we have a chapter that looks on Alzheimer's disease, focusing on the failures of science and ethics. And then we have Adam C. here, who actually co-authored this with my co-editor, Kimberly Jane. She unfortunately cannot be here today. She's based in London. We will have a book launch in London as well on the 8th of March. So she will be hosting that. Adam is going to present his part of the paper, which focus on the ethical concerns of behavioral research on captive animals. And then we have 2 chapters on animal-free education and training, and Charlene Gala is here today to talk about that. And then we have part 7, we talk about the advanced human biology-based approaches, and we are going to hear a talk on recent developments in alternatives to animal testing. Katie Taylor from the UK couldn't be here with us, but we have her colleague who's going to speak, so that is wonderful news, Laura Rego Alvarez. And then we have many more chapters, and the last chapter, as Thomas already said, is going to be my boss's chapter on research and testing without animals. Where are we now and where are we heading? And then in the very end, we will hear the author speaking of the afterword, John Gluck. And also John Gluck was so nice to help me with the moderation today, so I don't need to do this alone, since my co-editor couldn't be here. So I'm very grateful for that. I just briefly want to acknowledge the people or the charities who actually made it possible for us to gather almost 12,000 euros. That's how much it cost to publish this open access, because it's also over 700 pages, just to give you an idea how big the book actually is. And so we got money from Lush Charity Pot, from Cruelty Free International, from the Lush Prize, the American Fund for Alternatives to Animal Research, from a Swiss organization called Ärztinnen und Ärzte für Tierschutz in der Medizin, from Safer Medicines Trust, and a private donor. And I also want to thank our peer reviewers for their input. And we also want to thank Anne Van Keeling, who's an Australian painter who actually painted Boo, who is a long-tailed macaque, and she was used for research in the UK and now lives in a sanctuary in the UK. She was rescued by Animal Defenders International, and she made it onto our book cover. So thank you very much. Now we will start with the first talk. Jim, please come up. So Jim is a veterinarian. He's a professor at the University of Nebraska Lincoln, and he's going to give us his talk. And I just hope. Let's see. So I will put this away. It should be somewhere here. Which one is it?
I remember what I called it. There it is, right there. Yeah.
Okay, thank you.
Good morning, everybody. First of all, I want to thank Catherine and Kimberly for putting this together. Oh, sorry, I got to use the mic. Catherine and Kimberly for putting this together. It's been I know it's been a great effort for her. So Thomas said to try to be optimistic, and maybe mine's a little bit more pessimistic talk. So I'll get started here. And my background is I did some biomedical research in the past, but most of my career has been doing what we call production veterinary medicine, which is factory farm medicine. I've got out of that, but that was sort of my history. But I'll cover both. So the things I want to cover are what are some of the costs and drivers of the waste in the research system, and go through some of the reasons for that waste. One, sort of as animal models don't work a lot. I know someone's covered that in detail. Mice are not people. It's hard to extrapolate from animals to people in many cases. I think in laboratory animal or animals in research in particular, there's an irreproducibility problem. You can't repeat it, and science is based on repeatability. Sorry. So if you can't repeat it, it's not science. So it's more anecdote. And then the real big issue for loss of or wasted money and wasted animals is the failure to translate. That means to go from the lab to the bedside on the human side. And the same is also true on animal research. There's a big failure there in what I'm calling industrial livestock research. Industrial livestock is a little bit different. The biggest waste and expense, it's much smaller. It's about 1% the size in terms of money of biomedical research. But the big problem in livestock is the money is small, but the unintended consequences are huge. So the real waste is the bad things that happen as a result of the research. So it's a little bit different model.
Could you focus that microphone?
Let's see, it's kind of hard to, okay, I'll have to lean forward. Is that a little better? I'm sorry. I have a sore neck. Anybody here a chiropractor? Okay. So the real question is, and this is a general question for the whole group, is animal research sufficiently evidence-based? Is it fiscally justified, which is my focus? Is it ethical? Is it beneficial to society? Given that no animal experiment, however ridiculous, useless, or painful, or expensive, is illegal. And that's a picture of, on the upper right, that's a picture of Louis Pasteur when he did the first successful rabies vaccine. There have been successes in biomedical science, but on the bottom, there's been lots of failures too. And I think there's alternatives to that that maybe can decrease that failure rate. Okay. There's a famous quote from Dwight Eisenhower, and he said, "Beware the military-industrial complex." And now we still have that. It's even bigger. But we have also what I call the biomedical, also congressional complex, which is huge. And then the agri-food industrial complex, which is much smaller, 1%. Well, maybe not 1%, but it's much smaller than the biomedical one. So I think there's a great analogy there. And I like to look at it, maybe this is kind of harsh, but as a sort of a parasite-host relationship. The taxpayers are the host. They're supplying most of the money. Both agricultural and biomedical research are highly subsidized. So the losers, or the hosts, are basically the conscripted animals. And I don't know, who knows what that number is. I've seen numbers as high as 80 million, because we don't know what the mice and rats are. Who knows what it is? Maybe it's 20 million. Unfortunately, AWA doesn't let us know. Taxpayers' foot, probably about $45 billion. Oh, I should say this too. The numbers are very fuzzy. I did a lot of research trying to find the numbers, and they're obfuscated. Is that the right word? It's really hard to get exact numbers. So I think my numbers are imprecise, but I think the conclusions are still valid. You just can't get the exact numbers. So taxpayers and the animals are the big losers. Other people as well, when you have unsafe products entering the market, for example, in clinical trials, or even that make the market. And the winners, or the parasites, again, that's harsh, especially being here. I don't want to insult Johns Hopkins, since they're the biggest winner in the biomedical world, about $500 million, I think. Our governments, academia, indirect costs, big pharma and biotech, big ag, the healthcare sector, and the sutlers, that means all the people who sell biomedical equipment, sell the rats, and all $12,000 rat treadmills and things like that. And publishers make about $1 billion a year off of biomedical publications. So again, about 45 billion is the best number I could find out. NIH is about 83% of that, but there's also FDA, USDA, lots of other agencies that either funding research, doing research, or funding testing, or requiring testing of animals. So your view of whether there's waste in biomedical or agricultural research really depends on your viewpoint. All the people on that previous slide on the right think it's a great deal. People on the left, they may not think it's a great deal. So it really depends on your perspective, whether you're a host or a parasite, if you will. Again, that's harsh. Why is that other thing? Okay, never mind. So if you look at the history, at least my review of it, of biomedical animal research, it functions fairly well in determining basic biologic phenomena, like physiology, maybe mechanism of disease. Where it fails at a very high rate, as high as maybe 80%, is when you use animals as stand-ins for human disease. It just doesn't work I would say it's a functional disaster and usually unsuitable. And fortunately now, as other people talk about, there's alternatives to it. So here's the temple of biomedical science. It basically has two pillars. The basic or preclinical sciences, which emphasize discovery, and a much smaller amount of money and effort is spent on confirmation, which is a big problem. And the second is toxicology or safety. I think Dr. Hartung said about 10%, 20% of animals are used for toxicology. And then the high priests and priestesses are the scientists. So that's, if you look at that as your basic model, that works. So here's another expression of that. Am I going too fast? No? Okay. Of the biomedical industrial complex, I'll call it research ecosystem. This is basically the same as the previous slide. You have the three main components. Does it have a pointer on it? It does. Okay, well, you probably can't see it. You have the basic or preclinical sciences. Most of it's rodents. At the same time, you've got probably regulatory and industry work with toxicity testing for drugs, vaccines, chemicals, cosmetics, pesticides, things like that. And they feed into the clinical trials via the translation process. But in basic and preclinical science is broken up into two big parts. Discovery, where they spend a lot of money because there's rewards for new things. Very few people want to show that this worked already, even though that's a really critical part because science is defined by repeatability. If somebody else does it, repeats it, then it's true. Unfortunately, a society or salaries and all the things don't reward that kind of work. And we'd probably sort out a lot of decrease a lot of the use of animals instead of doing new things if we repeated to make sure that they're true. Because a lot of the problems come down to the translation process when you go from preclinical to the clinical mode. Now here's an example. I don't know how recent this was. I don't recall where I got this, but this is the animal testing that could be required for pesticides by the EPA. So you're looking at oral, dermal, reproductive system, the eye, the lung, DNA mutations, carcinogens, immunosuppression and things like that, and prenatal toxicity in multiple species and at multiple ages. So you can see the burden, and some of this is regulatory, so there's no choice. So there's a regulatory part of this as well as maybe a mandatory part of it. But this is just a good idea, and again, toxicologists, you can probably tell me more about this if this is still correct, because I'm not sure. I don't know a lot about the toxicology side. Okay, so this is where it's kind of fuzzy, but this is all the biomedical, and the best I could get, there's about $120 billion invested in the US per year in all animal R&D. And the one on the left is everything, industry, government, nonprofits, academia. And the one at the top, where it says animal research, is about $28 billion. About 1/4 of the total amount of money that's spent on animals is animal research. So about half the, and then if you look at the blue, the baby blue, that's the clinical side, which is about half. And the preclinical side the basic research is about half, and about half of the preclinical is animal. The other part is, laboratory-based and cell-based and things like that. If you notice, industry is higher than government. Within the US government, NIH is, it's about $45 billion. NIH is the gigantic proportion of the biomedical research, which everybody in this room already knows, I'm sure, about 31%. I'm sorry, 31% of the total US R&D. Now, if you look on this curve, on the far right, that's animal ag. So you can see it, you can't even see the bars. It's minuscule compared to about 1%, I think. So I'm going to show the animal ag. It's similar breakdown, but again, it's about 1%. Instead of 120 billion, it's 1.4 billion. It's broke down about the same. The one advantage, if you will, in animal research is that you don't have to use animal model. Usually you can use animal directly. So that there's a little maybe better translation chance than there would be in humans. But the breakdown's the same, except that government, unlike the biomedical side, government provides more of the funding than research, more of the funding than industry, excuse me. So Friedman has a nice paper, 2015, where you can, and other people have shown this in general in science and it's also true in animal research, that anywhere between 50% to 89% of the research is faulty, non-repeatable, wasted money, basically. And that's what those two red bars, the blue bar represents of all the money spent, 29 billion animal research, and from that, about anywhere from, I'm guessing here, 14 to 24 billion of that is wasted money. Animal research just does not work very well. And most of the rest of my talk here is going to be about why does that happen? What are the drivers of that waste? It's very similar on the animal ag side, you just can't see the numbers. So we talk about animal models. The basic problem, as everyone in this room probably knows, is they're non-predictive. Not always. They're biased, and they have a process of bioinfidelity. I made up that word, but I can't think of it. That was a word I made up, so I'm not trying to describe it. I did a lot, for many, many years, almost 2 decades, I worked on this bacteria called E. coli 157. It's a cattle, normal flora, humans is a pathogen. And if you look at E. coli K12, the most common research bacteria strain probably, they're very closely related, but they're hugely different in their properties. So, and a lot of people would use K12 as a model for E. coli 157. It doesn't work. Look at a dog. Dog probably has more diversity than any other animal mammal species. Is a Chihuahua the same as a wolf? Probably not. Some components, but a lot of differences. So even within the same species, there's a huge difference. Now we go to like a human. There's a rhino mice is a model for human rhinoviruses. And if there's that much difference between a dog, a Chihuahua, and a wolf, how much similarity can there be between a mouse and a human? Even when rats and mice, they predict each other, closely related, only about 60% accuracy. So that's sort of a logical argument, if you will. So I got a couple of examples here. I looked up on smoking. So we have billions of human cases every year for decades, and they're still doing experiments with smoking. I know I talked to somebody who knew about I'm not sure, it might have been Justin Goodman from, is Justin here? The organization, White Coat Waste Project. He said that these mice will be in here for 4 hours at a pop, inhaling basically pure smoke every day. So the assumption they make in the pharmaceutical industry is a high dose for a short time equals a low dose for a long time. I talked to, about a month ago, to a rep. He said they never validated that. But they do it, I suppose, in the sense of money. And a number of papers, 293,000 PubMed hits on using animals modeling smoking. Rats, 3,000. Primates, about 10,000. So it's being studied to death, is what I would say. Here's one I heard about. You probably heard of the forced swim test for testing for depression. You put a mouse in a bucket of water, basically, and he struggles and struggles, then eventually gives up and he just floats. So when he floats, that's called a depressed mouse. They have a term for it, which I didn't put here. And then, you give the mouse drugs, and if it swims longer, it's no longer depressed. And this, you can watch a video on YouTube if you want to see what it looks like. So when it's floating, it's depressed, you give it a drug, and it swims for longer. So I was thinking, if there aren't any psychologists, any psychiatrists here, but if you were, I've taken antidepressants before, if you were forced to swim in a deep pool and to diagnose and determine your treatment for depression, I'm making a logical argument here. I don't think it would work. And yet, there have been even more. 6,500 publications since 1977 when it was invented. I think it wasted many mice and rats and labor and equipment and time and papers and taxpayer dollars. And I looked on some people think it works, some people don't, but there's a developing skepticism about this technique. There's been no new class of antidepressants in about 30 years. That was the SSRIs, the serotonin reuptake inhibitors. I can't think of what the other S is. And one of the reasons, maybe they're using an invalid test. It doesn't pass the logic test. Another example is the chimpanzee. When is 1% greater than 99%? They've used chimpanzees, in theory they should work great, predicting human outcomes, but actually they've largely failed as an animal model. Usually they're subclinical for human diseases, did lots of work with HIV and vaccines, none of them worked. They're overbred in the 1990s on the assumption they make great models for HIV, so the 1% DNA outweighs 99% similarity. In the late 80s and early 90s, there was an affaire du sang where they thought since chimpanzees couldn't get HIV, they thought that humans' blood infected with HIV would be okay to transplant. So they used it to transplant, and they were hemophiliacs, and something like 1,200 people got HIV because of the assumption that it was safe and it didn't cause disease in chimps, so it didn't matter if it was infected. So it cuts both ways. So another issue is irreproducible, non-repeatability, unreliability. These are kind of artificial breakdowns, but sometimes repeatability means you repeat the experiment under the same conditions, for example, in the same lab, you get the same result. The other one is reproducibility, where you change the conditions, maybe you change the species, or you work in a different lab. Both of these are problems in terms of failures, I guess. So here's an example of some of these. For cancer, for biomed research in general, only about 50% of academic studies in the top journals are repeatable when conducted by the pharmaceutical industry. The most famous one was Amgen, where they looked at cancer compounds, and 47 of the 53 failed reproducibility when they went in their own labs. And that cost $500,000 to $2 million apiece, 3 to 24 months of time. That's one of the reasons the pharmaceutical industry, as was mentioned in Europe and I think in the US, they're decreasing use of animals because they're non-reproducible, or at least the academic community that's producing the animal models is not reliable source of information. And here's a quote from Francis Collins, who acknowledged that reproducibility from just 4 years ago is a problem in biomedical research, and that animal models are in preclinical work are driving that failure of reproducibility. So it's known at the highest levels. So here's moving on to translation now, and this is the biggest source of wasted money in biomedical research. So about, say, for every 10, this is a little bit fuzzy, for every 10 to 15, every 5 to 10 compounds that are potentially shown benefit or utility in animals, about 250 of those get screened to be preclinical and go through the process, and one of those will become FDA approved. So you've got a very, very, very high failure rate. And there's two things in the translation process, they call them the valley of death. And very few cross that first valley of death is going from preclinical and just getting to early clinical testing. And this is where a huge number fail. There's a second valley of death when it's in the clinical process. Maybe it's the drug absorption or some other element that makes the drug incompatible with being marketable. So and then beyond that, it has to be adopted by clinical practice, and it has to have benefits to society and be widely dispersed and adopted. So there's huge barriers, but the biggest one is jumping from animals to people. That's the biggest valley of death. So why does translation failure, in spite of, compared to the past, more money, more animals, more trained people, more resources, more facilities, more technology than ever before? So it really doesn't make any sense. Why is that happening? I'm sorry, this is kind of a busy slide, but since translation failure is the biggest one, I want to go over it a little bit. So I talked about irreproducibility. Pharma can't replicate academia. Compared to clinical sciences, preclinical research is a wild west. It's a lot of poor practices, rush to publish, poor quality data. High false positive rate. Again, most compounds fail. They're either toxic or clinically effective. There's a false negativity toxicity. Post-marketing academics, Vioxx was the best one. In fact, my uncle died from a Vioxx heart attack several years ago, about 100,000 deaths. They tested in African monkeys for cardiac safety. It was fine. It didn't work out that way in people. And there's about 16 million adverse post-marketing events in the past 30 years. Again, all of those aren't due to failure of animal testing, but a good chunk of those probably are. And then the false positive, where aspirin's approved in 1900, but if they post-approval, they tested it causes birth defects in many, many animal species. Penicillin kills guinea pigs. One of the first things you learn in veterinary medicine is you can't give penicillin to guinea pigs because it'll kill them. It destroys their flora, and then you got Clostridia overgrowth is what happens. Okay, so here's just a few, there's lots of these, but here's some translation failures for ischemic stroke. It's when you get a clot in the brain. This is summary data, like 2 of 500 they were protective in mice, rats, and rabbits. Only 2 benefit people. One of those was aspirin, so not a whole lot of progress there. Inflammation of sepsis. This was also a very famous study because sepsis is a big deal at severely ill people. Worked in mice, all failed in people, 150 clinical trials, and then for ALS, very similar. It turns out the corgi actually is a good animal model. It actually gets naturally occurring ALS, which is maybe a better study of the naturally occurring disease than the induced disease in a real animal species. I think that would be one approach, rather than inducing disease. Just like reproducibility, translation's been known at the highest level for decades. In 1998, the director of the NCI said that mouse models of cancer don't work. So why are we keeping doing the same thing 20 years later when it's been known it doesn't work? I don't actually understand that, unless it's political or something. I guess it's the biomedical industrial complex. Okay, this next slide's a little bit complex. It's trying to summarize what I just said. So on the far left, you've got the preclinical animal. A lot of those are bioinvalid models. That leads to animal model failure. And when the animal model is known to fail, that's what the known mean, it becomes unpublished file drawer results or unreported trials. And that data is missing from the scientific literature. And that biases in favor of it makes the stuff that's published look better. So people repeat that because they don't know that it didn't work. On the other side, the animal model looks like it works. It gets published, but it's not reproducible or clinically sound. It's toxic or it's not clinically effective. That enters the literature, and that causes biomedical literature pollution. And the ultimate result of that is failure to translate into people. I mean, there are successes, but it's actually, if you look at it, it's very, very rare in terms of the whole process. So this brings to the myth of peer-reviewed sound science. In reality, there's no real bars. Anybody here publishes? There are really no real bars of publication. There's thousands of journals. Everything can get published. And peer review really decides where, not if, something is published. This is a mythical creature in Australia called the Australian traveler. I just liked how it looks. I put it in this slide. Okay, I'm going to move on to animal research. Am I doing okay on time, John? I've got that much time? 5 minutes. Okay. So livestock's a little bit different. Very different, actually. It's tax supported in the same way, much smaller. The goals are what's called production efficiency, where you increase the output with less inputs. You want to make cheap and plentiful food, and it's to feed the world, which is actually a myth. I won't go into that, which is what this famous sculpture is about. And how do you do that? You advance production efficiency, and the biggest problem is you address the unintended consequences. That's where most research is. I worked at this place called the Mineral Research Center in the middle of nowhere, Nebraska, for 26 years. It's the biggest research center in the world, 35,000 animals, 200 employees. It's basically a big ranch with a campus around it. 55 square miles. It's about 2.5 times the size of Manhattan. It's a big place. Those little green circles are pivot irrigation. So I worked on, this is a feedlot. The way you do production efficiency is you manage intensity, the prison model, you have feed efficiency, genetic selection, and pharmacology. And I did a lot of work in these feedlots. You can make a manure bath, you can climb the fecal mound, whatever you want to do. So what I worked on was E. coli 157, which is a big problem in feedlots since '93. It's a big ag priority. Cattle get colonized, contaminates meat, people get sick. I worked on this for many, many years, tried everything, it failed. My lab wasted at least $13 million on this. If you go look at this picture, do you think you could control any enteric disease if this was a human disease? It's impossible, and I didn't choose the research that was assigned to me, but if you look at this environment, there's no way when you're living in a foot of your own manure and sleeping in manure and climbing manure mountains that you're going to control that. And so eventually, it was unfeasible. But this is a blowback from the system. When you have this system, so this causes many, many millions of dollars to industry, both in kids, but also meat recalls. So it's kind of stupid science. So I wasted a lot of money. Here's another one at the mark. Want to make twinner cattle, so they increased the turning rate by genetic selection to 50%, but you're fighting bovine evolution, all kinds of health problems. They abandoned it after 30 years, after spending $100 million on this. And the funny thing is, if you're a cattle producer, you cull animals that have twins. Nobody wants them. But because the money is just given, it's allocated every year, it's non-competitive, they can keep doing it. I may skip the next one. Let me see. Oh, here's the most important one. This is cannibal cow feeding. In the 60s, USA did research, and they found that you can feed dead cattle, live cattle, and increases milk production. So then where I'm working at now, the University of Nebraska, funded by industry, scaled it up and said, wow, this works really, really, really well. And so then the Europeans adopted it. That's actually a picture of a warehouse. They call it meat and bone meal or animal flour. That's a warehouse. They fed it because they don't have soybean there. Protein's expensive, so they fed dead cows to live cows. Of course, that led to the mad cow disease and maybe 250 human cases, but it cost billions and billions and billions of dollars worldwide. So again, the blowback, the research investment is relatively small, but the consequences are huge in terms of wasted dollars on the public side or industry side. So it's a different model from the human side. Okay, here's my how am I doing, John? Am I about there? Oh, 3 minutes? Okay, then I can do this. Okay, so basically, if you want to sum it up, on the human preclinical research, we say animals are people. And on the livestock side, we say animals are machines. So both models are, for the most part, wrong or are fatally flawed. On the human side, they're bio-infidels, if you will. They rarely translate. There's some blowback. On the animal side, we're trying to make animals do something that they're not really, put them in environments and eat things they're not supposed to eat. So it's a very unnatural system, and the biggest problem is the unintended consequences of blowback. Since I have time, I was going to end here. I'll give the next slide, which is a little bit pessimistic. So why do we continue to use animals even though they fail? One is the biomedical and agricultural industrial complex. Money talks. So they survive because a lot of people make their living off it, and I understand that. There's huge rewards for it, especially if you use new technology like CRISPR. I heard the Chinese just CRISPR'd some human embryos. And there's people. There's the person who lives right next door to me at Lincoln. He's a true believer. He's got the posters of the child with cancer, and he works on. There's mythologies on the animal side. We're feeding the world. On the human side, we're saving lives or preventing lengthening life. It's cheap. There's no penalty. There's really no penalty for failure. There's ignorance. People don't know about the alternatives, that there are alternatives, or the Maslow's law of the hammer. If you're familiar with this, it's if you're a hammer, you're looking for a nail, and they're used to doing that, so they keep doing that. And I think the mouse is the biggest. Mouse gets hammered a lot because people are used to using it, so they use a mouse. So unfortunately, this is the negative part. Because of mostly the money and the subsidies, I think change is unlikely now due to these perverse incentives. And to get the change that I would want and people in this room would want, you have to change the incentives, which basically means getting rid of some of the subsidies and providing good alternatives. I'll stop there.
We have time for questions. No questions? Yes.
Check. Marty Stevens, CAT. Thanks for your talk. On the agriculture side, just correct me if I'm wrong, but that research doesn't even have the minimal protection of the Animal Welfare Act. So you talked about the Wild West. That would truly make it the
Yeah, I would call it feral research. Federal animals, which would be USDA, they're exempt from the Animal Welfare Act. Livestock within a university setting, they are subject to IACUC and the AWA, but not the federal side.
Even when used for, meat production and fiber and that kind of, I thought that was all exempt from the Animal Welfare Act.
I'm not sure I understand your question.
Yeah, well, it's biomedical research versus agricultural research.
Oh, in biomedical research, they're subject to the AWA.
Right.
For agricultural research, they're not.
Correct. Yeah, that's my
That's correct.
Thanks.
I think it was Jesse Helms put that in. I'm not sure.
Thanks a lot for your talk. My name is Adam. I'm curious if you could describe briefly the mental state of the true believer. I'm a philosopher, so all of the stats, or most of the stats that you put forth are new to me, and they're very convincing. So what is the true believer, if there was a really smart true believer present, what might they say to you?
They would say that I'm saving lives by what I'm doing. And the other thing I've noticed about some basic biomedical research scientists, this is sort of a little bit different from that. They actually don't want to solve the problem because a lot of them focus, say, on one gene and one system, and that's the best model if you're working in an NIH system. You take one small piece, you keep working it over and over. And they actually, they may say they care about translation, but they really don't. There's a disconnect between the biomedical scientists or preclinical, they're mostly PhDs, and the clinical side, they are mostly MDs, and they don't really talk the same language. And that's one of the reasons there's that translation gap, I think. Translation is the high priority. A lot of it's intellectual curiosity justified, I think, by the belief, and they truly believe it, that what they're doing is saving lives. It's this molecular reductionist model. If I modify this gene, it's going to translate, look at all those steps. It has to go through, there's a lot of steps to go from a gene to get to to think it's going to work, I don't know, 50 steps to get to a human being and it's going to work in a human, which is one reason that they fail. You've got this reductionist model is a huge problem. And I don't know the motivation, but they truly believe it. Maybe as much as you don't believe it. Thanks for your question, Adam.
Thanks.
Who else?
Thanks, Jim.
Yep.
Got
One more right here.
Ken Shapiro, Animals and Society Institute. Could you just comment on the relatively recent sophisticated developments in knockout genes and genome studies and so forth? Has that in any way increased the predictability or accuracy of animal research?
I'm not an expert on that, but my sense is that it doesn't, because what they've shown for most diseases, I mean, there's some that this is not true for, but for most diseases, they're what they're called polygenetic. It's a contribution of many, many genes, like for heart disease, for example. So a knockout of one, if you're using a mouse, knocking out one gene is probably not going to work. There's certain diseases where it is a single gene with a single mutation. I've actually a slide I didn't put in here with an animal model occasion of that, where that works, but it's not the case for most. And it may not be the same in the animal versus the human. So I'm not sure, did I answer your question? I'm not sure if I did, sort of. Yeah, I'm skeptical of the knockout model myself.
Also, we have a wonderful chapter in the book by Jared Bailey who focuses on genetic modification of animals, and especially now the CRISPR, the hype about CRISPR, this new technology, and he assesses the scientific side as well as the ethical problems. So, yeah.
Thanks, Jim.
Okay, thank you.
Our next speaker is our host that you've met earlier, of course. And Catherine is by profession a veterinarian. And when I first met her and talked to her for a number of in a number of opportunities, I came away saying, well, this is a professional on fire. And I still stick with that. And I say it's a kind of fire that I've recognized that is not exclusive to veterinarians, but it is related to veterinarians who have worked in the laboratory and have seen the disconnect, the frequent disconnect between what we as principal investigators say our concerns for pain are and what actually gets done in terms of preventing pain. So I recognize the fire. Catherine's presentation today will be Refinement on the Way to Replacement. Catherine?
Thank you. Thank you for this kind introduction. Let's see. I always have problems with this mouse. Sorry, I have problems with this mouse. Can you help me, please? I don't know. Because the mouse doesn't, you know. Oh, no, but you know, the mouse never works. That's why I'm like, okay, sorry. Okay. Okay. Why is that so weird? It doesn't go. Sorry for this. For some reason, it shows here and not there. Look. I don't know why.
I don't know.
Because guess it should be, what the heck? What happened?
What are you trying to do? Just get it to play?
I'm sorry, we tried this before and it worked, and now it doesn't continue.
There you go. Okay, there you go.
Is it working now? Okay. Sorry, I don't know what the problem was. Okay, so I wrote the introductory chapter of the book about the application of the 3 Rs in practice, and I especially focused on refinement since this has been an area that I've been have been working on a lot. So that doesn't. Okay, you know, can I just ask something else? It doesn't move here. Sorry for this, but
Doesn't what? I'm
it
sorry.
doesn't change here. You know. Why is it? Okay, wait.
I don't know. I don't use this PC.
Oh yeah, now it's okay. I don't know what happened here, but okay, sorry about that. Okay, so I start out with the 3 Rs principles because I think that people might be in the room who haven't heard about those principles. So Russell and Burch, 2 British scientists, they introduced those principles of replacement, reduction, and refinement almost 60 years ago. So actually now where our book is going to be published next year, it's kind of nice, it's the 60th anniversary of those principles. And the goal of those principles was to eradicate inhumanity towards animals by avoiding their use wherever possible and improving significantly the treatment of those that still seemed to be necessary to be used. And they also wanted to refine the quality of scientific and medical research and testing. So what do those 3 terms stand for? Replacement means that you replace animals with non-sentient material. Reduction means that you reduce animals used, but you also reduce in the number of experiments. And refinement refers to everything that you can do to reduce the suffering of the animals. And newer definitions of refinement also include that you try to improve the well-being of those animals. So you also provide them with positive mental states. And so the 3 Rs can not only safeguard animals, but they can also improve scientific rigor, reproducibility, and ultimately translatability. God, I don't understand this. So to start out with the public concerns, I think many of you have heard that there are increasing public concerns, and they are reflected in the public polls about the use of animals in science. And these concerns have been drivers for political change by implementing more progressive legislation. For example, in Europe, we have Directive 2010/63 on the protection of animals used for scientific purposes that has the final goal of full replacement of live animal use. Having such strong legislation, one would think that we could expect the incorporation of the 3 Rs into this incorporation of the 3 Rs into the legislation would result in changes within the research community, particularly with moving towards replacement of animals. But unfortunately, the numbers speak a different language. To say up front, we don't have exact numbers because, for example, in the US, as you know, certain species are not counted. Mice, rats, fishes and birds are not counted. But there are some estimates. And what has been shown is since the 2000s, the numbers are actually increasing. And we have one estimate for 2005, it said 127 million living non-human vertebrates were used worldwide in experiments and to supply the biomedical industry. And for example, for the use of fishes, since it is really on the rise, there are estimates that in the US alone, there are between 3.5 and 7 million fishes used. And And most of those animals seem to be used in basic and applied research. In the European Union, it's estimated that 65% of those animals are actually used in basic and applied research. And not included in current statistics are animals that are bred for research, but that they are not used. They are so-called waste animals. Right, what did I do here? Okay, right. Okay, so the 3 R's application and practice, that was my big question for the chapter to start out the book. When you look at the implementation and the impact of the 3 R's in practice, it looks like the laboratory animal science community has been very interested in refinement. And there has been increased refinement research in the past at least 20 years, and especially now in the past 10 years. However, the improvements cannot be achieved unless this increased knowledge is translated into practice. So this was my research question also for my PhD. Is refinement actually applied in practice? So all those, of course, are measures to safeguard animals. I focus on the refinement of housing and husbandry, experimental refinements, and I also included a refinement of planning, conduct, and reporting, because this is very important to make the research reproducible and potentially translatable. And the harm-benefit analysis is another tool that I want to talk about briefly, because it also can, it is there to safeguard animals. I have to go through this very quickly. You have many examples in the chapter about husbandry issues and what has been researched in terms of environmental enrichment. I just wanted to start out with a quote by Russell and Burch, because they already recognized that husbandry is a factor of contingent inhumanity in all types of experiments, because animals spend their life in a captive environment, which is very different from their natural habitat. And for example, the cage floor in a standard mouse cage is 280,000 times smaller than the animal's normal home range in the wild. That was calculated by Lavis. And animals are deprived of most of their natural stimuli. And the consequences of the so-called controlled deprivation is that the animals in such captive environment are abnormal and unhealthy, and it changes their behavior as well as immune, nervous, and endocrine functionality. I just listed some examples, just to say some brief things. They have an altered immune response, they have enhanced tumor growth, they have altered organ development and metabolic and growth and reproduction rates and behavior. So there are many issues. They are definitely different. And also those so-called control animals that are supposed to represent the healthy individuals, they are also metabolically abnormal, and that's, of course, problematic for the research results. So there are a lot of challenges when keeping animals confined in the laboratory. And the goal of refinement is also that you want to provide well-being for those animals. But well-being can only be achieved if the animals can experience positive welfare states, which require a responsive environment the animal can engage with. And this is difficult in the laboratory. And this is also a way for the animals to cope better with the stresses in the environment. However, the current, the best, highest requirements, which are still minimal requirements for housing, are still insufficient in meeting most of the needs of those animals. For instance, there was a study highlighting that over 20% of mice who lived in enriched cages still revealed stereotypical behavior. And another researcher, Sarah Wells, she demonstrated, because she filmed during the nocturnal phase when the mice were very active, she filmed them and saw that many of those abnormal behaviors are displayed during the night when we normally don't monitor them. At least most of the laboratories don't. And then, of course, the thing is there's this repetitive abnormal behavior as well as other abnormal behaviors. For example, depression-induced inactivity. This is actually maybe even a bigger welfare concern. as they are discussing it now, then those animals that have stereotypical behavior, they sometimes even, was found that they cope better with the environment than the ones that just are very inactive and depressed. So there are many challenges. The next area I want to focus on are the experimental procedures that should be refined. This is something I did for my PhD research, where I reviewed over 500 original animal research proposals from around Germany. And I actually looked at the refinements that were planned in the areas of anesthesia, analgesia. I looked at the so-called humane endpoints and the killing methods, and I also looked at you have to do a prospective severity classification. I looked at that as well. And it's also at the monitoring practices for post-surgery. And there are many results, but just to highlight, for example, the post-operative pain management appeared to be poor. There were some issues with the agents and the doses and duration, but also for about 30% of the surgical procedures, no post-operative analgesia was planned. And following 10% of the proposed surgeries, researchers planned to give the pain relief only if they thought it was needed. However, in the proposals, at least, we didn't see indicators for a structured pain assessment. So we also looked at the severity of the procedures. There are certain so-called pain catalogs that are available in Germany, Switzerland, and now, of course, the EU directive has also they classify those procedures, and we looked at them, and then we looked at what the researchers kind of estimated. Of course, this is a prospective estimate, and almost 60% of their estimates were lower than the ones we did according to the catalogs that are available. And of course, this was only an example from Germany, but it's likely not to be an isolated case for animal laboratories in Germany. And when you look at the literature, there are numerous structured and systematic reviews of the published literature, and they also indicate that there are a lot of flaws in the application of refinement methods, namely analgesia, anesthesia, and also the type of killing method. So there is this indication already, and it seems, looking at our proposals, it seems that could be really what is happening in practice as well. So to sum up those two areas, inappropriate housing and husbandry, as well as deficiencies in the application of experimental refinements, need to be avoided, not only to meet legal requirements, but to avoid needless animal suffering. And then I also looked at the planning, conduct, and reporting, because we've heard before that we actually have issues with quality of animal research, and not only animal research. Of course, we also have issues of still with in vitro methods. There have been guidelines to improve that as well. But the refinement of these areas, planning, conduct, and reporting, is essential for ensuring the internal validity and reproducibility of results. And besides the fact that many animal experiments that are performed never get published, a large part of what does get published seems to be incorrect. John Ioannidis argues that it is highly probable that most published findings are indeed false, and he drew his conclusions from conducting simulation studies and systematic reviews, and he calculated that at best only 1 in 3 publications took basic precautions to minimize bias. So this is a very important area where we have to refine. And since legally required animal data forms the basis of decisions to move forward to human clinical trials, flawed animal research is additionally problematic. And most published in vivo research is at risk for bias, as there is a large number of potential sources. For example, so definitely safeguards to avoid bias in study design, conduct, and analysis include randomization of treatment groups to eliminate systematic differences between them, blinding of investigators, to treatment and to handling of data and reporting on sample size estimation. And also analytical errors may account for close to a quarter of the irreproducible studies. Just to name another area of bias is the selective reporting, and that's of course from an animal welfare perspective very problematic, because on the one hand we have negative findings, studies for which the original hypothesis was not proven, that are not published at all. So it's possible that those are done by somebody else again, they are repeated without the other researchers knowing. And the incompletely published studies, for example, with whole experimental groups excluded when the reported parts of the study offer results that demonstrate that the treatment is effective, even though it is not. That means selective outcome and analysis reporting bias. That's another big problem. This is why we also have this overestimation of significance of many animal studies. And then they move to the clinic, and then they are proven not to, like they are not effective, or they are even harmful for the human patient. Just a few words on the harm-benefit analysis. That's something that is a key element in, like, for example, in the German legislation, this was a legal requirement, has been a legal requirement since 1986. And of course, also the European directive, that is a major part of it, and it's the tool to safeguard animals, because the idea is that the hope for benefits of the research, they have to outweigh the expected harms to the animals in terms of suffering, pain, and distress. So it's really a cornerstone of animal research regulation and a key protection for animals. And it is, of course, a difficult analysis to do, because you have the hope for benefits, and then I think this is very hard to predict sometimes, and also for the harms it might be easier to have a prediction for that. What has been seen, I used to be an inspector of animal research in Germany, and I had to assess a lot of research proposals, and I saw that even when it was a basic research proposal, the hope for benefits were oftentimes really exaggerated, because it seemed like this is going to be the next cure for cancer, even though we were talking about basic research. So it was very difficult to assess those harm-benefit analyses and do your own one, because there's no general tool for assessing harms and benefits in a transparent and justifiable manner. And the general lack of transparency about harms and benefits in the US and also in Europe. In Europe, we at least have the mandatory retrospective assessments, but this is really the big problem. We have a lack of transparency there. What I want to add about the European Union, those retrospective assessments are wonderful if they would get published. So that is that the competent authorities in the European Union have the possibility to assess every experiment that was conducted and licensed and conducted, and later see if the SVRs were, if everything was applied, everything was done according to the proposal, but also if the outcomes were as expected, and if actually the harm-benefit analysis was correct. But as you can see, there are not many countries in the European Union who make those publicly available, and I still haven't seen any, and even so we have the directive since 2013. We already heard a lot about the reproducibility crisis today, but this is actually, of course, the big issue we have, because this crisis, some call it a crisis, is considered to be due to the poor experimental design, conduct, analysis, and reporting. But also it's also influenced by inappropriate animal housing and handling. And also if you have insufficient pain relief, that can also influence your results, as well as the other refinements that are absent. And because most animal research is being justified as indispensable to furthering human health care, we actually have a bigger issue. It's the translatability crisis. And yet the translational rates, success rates from animal studies to humans are still poor despite the measures that have already been taken to improve quality. We have now a lot of reporting guidelines. We have new prepare guidelines, but we already had the gold standard publication checklist since 2010. There is a lot of talk about those issues within the laboratory animal community. So it is definitely, everybody seems to be aware of this problem, but still that hasn't seemingly improved the translation rates. In most areas, it is actually between 0 and 5%, and when it comes to drugs, less than 12% of drugs entering the clinical trials result in an approved medicine. We heard this before. Just a few things. The question is, why are those animal models not so predictive? Within the animal research community, it seems that everybody is talking about, we need to improve the scientific quality and the internal validity, and we have to improve the reporting so things can be reproduced, and then things can be fixed. The thing what is not talked about, at least I haven't come across that in the animal research community, is that there are insurmountable species differences. There was just a new paper out from Pound and Riskes-Heutinger emphasizing on this again, that there can be a lot can be done to improve the internal validity, but for the external validity, we really have some issues that won't be able to be resolved. So I don't know who of you saw this. There was an article or an interview with researchers. It was, I think, in Lab Animal, and it showed that actually nobody talked about species differences and that this could be an issue. And so just to emphasize on this a little bit more, the human to be modeled does not exist, as human genetic polymorphism results in indefinite diversity, which is further complicated by other illnesses and the variety of different lifestyle factors and exposure to many other different factors. And so it is clear that animal research has furthered human health care in the past, but it seems like today we are dealing with a lot of diseases that are multifactorial, that are often chronic. They're of course, human-specific illnesses, and the problem is most of them we don't really understand the underlying mechanisms. Alzheimer's is a good example for that, and this is why it seems impossible to mimic this in other animals. So just to sum up and think about what can we do to change the situation and to move away from at least the animal models that have been proven to be not successful. As you saw on our emphasis in the book, we really think that critical appraisal of animal experiments and animal models is crucial, is like the key part we have to work on. There are different tools to do that, systematic reviews. We have those in our book as well, citation analyses, retrospective assessments. All those have to be done, those studies, to really evaluate the adequacy of animal experiments in predicting human outcomes. And also we should focus on timely non-animal techniques that have the potential to replace animal experiments, plus on novel approaches, because we don't need to replace every animal test with a non-animal test. They're definitely enough. We can just let go, and we have to find a different approach to doing this research. What is a big issue that will definitely come up is that we need financial investment in human relevant research. When you look at NIH, they are the biggest funder in the world, and still it's hard to get money from them purely for non-animal methods, and so that's a problem. And we need a lot of more education and training in animal-free, human-relevant methods, because at the moment this is also an issue. If you cannot train young scientists, how should they find a different path? So yes. So I want to end with the quote that I took from chapter 20, which is actually on Alzheimer. Wherever one stands on the animal use ethical spectrum, hopefully all can agree that the conduct of frightening, painful, and lethal experiments on sentient beings, whether mice, dogs, or monkeys, is unacceptable when the research translates in no significant way to human benefits despite decades of efforts. Thank you very much. Any?
I'm a PhD student here at Hopkins. I want to ask about the last point that you make. So in terms of educating the next generation of young scientists, what areas should be focused on in terms of educating students to increase reproducibility in scientific research?
Okay, so I was actually, of course, we need definitely more education about improving the quality of what is done at the moment. But what I think is a big area where we still are lacking education is in new approaches to basic and applied sciences, because at the moment there's a lot of focus on testing, but there's not so much offered actually in basic and applied research where you don't use animals. There's a summer school next year from the Joint Research Center. They have a focus also, I mean, they cover the whole spectrum, but they have a focus on basic research. And I hope that CAT is going to have a course just focusing on that. That would be something I would like to push forward, and I hope Thomas will be, I think he will be on board. So yeah, so this is really the problem. I mean, there was one course at UC San Diego, I think. They had it running for 1 year maybe, where they focused more on this basic research area, which you saw is consuming the most animals, and it's not running anymore. And I know that Charu is planning something at the Center for in Canada that is focused on replacement. So that's very hopeful. And then there's actually one course. Now I'm remembering everything now. But there's one course planned at the University of British Columbia, but it only starts in 2020. So slowly there are some courses coming up. But look at how many people go in this field because they have no other options. I don't think that everybody wants to do animal experiments, but if this is kind of the normal path and you don't see any alternatives, and even our center is a very well-known center around the world, but when you look at how small it is and how few people we are, we just need more more people focusing on this area of education. Yeah.
Thank you for your talk, Catherine. Most people, researchers and research institutions, respond to incentives and disincentives, which usually means money. So what incentives or disincentives exist now for refinement, and what would you propose would be good incentives or disincentives that don't exist now that would lead to more refinement?
Okay, so okay, maybe I first give another answer. I just remember when at the institute where I did my PhD, one researcher told me that actually today you only get money for animal welfare research, which I found interesting. She was a little bit annoyed about that actually, yeah, we have to have a refinement topic to get funding. That was actually a project on carbon dioxide killing. No, let's not call it euthanasia, killing. So there seems to be some money for refinement research, but I would say that we should really focus on moving away from animal models, as this has been proven to be not the best models in many areas. I'm not saying any area, but there are many areas where we could focus on moving away from those models, and there seems to be not enough money for that. So yeah, actually we have to definitely change the way people are rewarded for their work. And also here I heard from a researcher that if you don't do animal experimentation, you actually don't get the funding. And then you can not even open your lab. So it's very sad. The system at the moment is yeah, it's not ideal, and we have to. That's actually why I decided to initiate this book project, because from my work as an inspector at the competent authority, I just saw that there are so many issues. I mean, there are the issues I talked about now, but there's also the issue that even if you try to do something from a legal, from the legal perspective, you can hardly stop any animal experiments, because this is just the way we do it, and this is so hard to break through there. So I think we have to address this issue from all angles, as we did with our book. I mean, we focus on the economical issues, as you did in your chapter. We focus on ethics, we focus on the lack of translatability, we focus on that we have responsibility towards the patients who are actually waiting for cures, and obviously they are not produced to that extent. Yeah, we just have to try to find many ways. And one is, of course, also that everybody who is doing non-animal or is doing work with non-animal methods is actually also an advocate for their work. I kind of observed that, of course, I also know people that advocate for their work all the time, but some people just do their own thing and they are not bothered what other people do. And I think we have to speak up and also talk about why it makes more sense to not use animals and use human biology-based models. Of course, it's still a long way to go, but when you look at how little money is invested in those new technologies, like organs on chips, for example, and what the output is, when you talk about the return on investment, it looks better to me. So that is definitely... I mean, sorry, it was maybe a long answer, but yeah, there are many areas we have to work on, and we could do something, and I guess everybody has their focus. I decided, of course, in my job I can teach. That's maybe the best thing I can do. But other people are maybe good at lobbying, or so, yeah.
Hi, I was wondering kind of like what you would say that our role is as like being part of Johns Hopkins University, which is a very large research institution. And for example, I know that like some of the experiments that like Jim was talking about earlier, like with the antidepressants and the mice, I've seen like documentations that like that happens at Hopkins, for example. And I was wondering kind of like with Kat being like at the Bloomberg School and everything like that, and I'm an undergraduate student. I'm co-president of like our like animal protection organization on the undergraduate campus. I was wondering kind of like what we can do, and like aside from like maybe you said like we should stand up and we should educate, but like what exactly can we do as like being involved in the institution, and if we are upset at something that we see, what is our place exactly in our role?
Yeah, that's a difficult question, of course. But I think to talk to people is the first, like to talk to the people around you, to other students is very important. The other day I was sitting in a bar, and then there was somebody sitting next to me. I started talking, or we started talking, and then it turns out that he's doing research on, he's doing brain research, and he's using cells from mice. And then I told him about our mini brains, and that it doesn't make sense to use cells from mice, because that just that won't be translatable. And I organized for him to have a tour and to see our mini brains and to see the models that are used at CAT. That's, I think, the very important, that you really talk to your colleagues and to your students, because the problem is there are different thought cultures in the school, and it depends what you're exposed to, I guess, and what information you get. But I think it's time that we refocus and we kind of try to be open for new things. And just because animal experiments have been declared the gold standard, we also have to face the deficiencies, and we cannot ignore them much longer. And especially at Johns Hopkins, which is a very renowned school, they could be at the forefront of alternatives. Yeah, but I'm sure Thomas is trying, so talk to him. I'm very sure he has more ideas.
Perhaps to add to this, because this is obviously an overarching question for what a center can achieve. On the one hand, it is clear this school alone here has 630 faculty members, and they're all PIs in their own standing, and they can essentially do what they want. What we are trying to do is to bring events like this here, and however, it is a very, very competitive thing already. You will not see very many people here out of the school today present here. You're one of the exceptions, obviously, from the rule, because in this building alone, there's 1,400 events per year. And against this, we have to compete. But this does not mean we cannot achieve nothing. We have been working systematically, for example, with surgery, to phase out some pig research or pig demonstration experiments in their education for medical students. We are trying to bring also increasingly lecture offers to the school and to Hopkins as a whole. So we're working with the School of Medicine also to now create some lectures and offers into Refinement. We already have for many years lectures on even a certificate program on animal and law and the opportunities of humane experimental technique. Our courses are going now more and more also to Coursera, so that they're available for free as remote courses, and I will give you an example in my lecture later. But it is an uphill battle, and it takes time, and I have to say, I would wish that being in this school, we would have more impact locally, but the philosopher is nothing in his own village. So we have very often better responses even from outside, requests now from other universities to create courses on animal welfare or contribute lectures. It is what it is.
Okay, I think we can move to the next speaker. Charlene Gala is next. Thanks a lot.
Oh, I'm sorry.
Well, you can see how energetic people are to get right up here and get into talking without even being introduced. But let me hold up the group for a second and introduce Shaylin Gala, Vice President of Lab Methods Group at PETA, a person who has been devoted to looking at medical training in various contexts in medical schools, military medicine, and looking for ways to replace the typical animal models that were frequently used for many, many years with human simulators. And when we met earlier, I was mentioning that when I was in basic training at Brooke Army Medical Center, I can barely bring to mind, because it was so upsetting to see some of the examinations and demonstrations that we saw about protections of how to treat sucking chest wounds, and it was awful. And I think very little, if anything, was learned. But welcome, Shaylin.
Hi, can everyone hear me? Okay. Good morning. It's an honor to be here with you today to speak with you. And I'd like to thank Dr. Herman and Dr. Hartung for setting up this important event to discuss this book launch. I'd also like to thank my book chapter co-authors, Dr. Pawlowski and Dr. Feinstein from Beth Israel Deaconess Medical Center and Harvard Medical School, and Dr. Marie Crandall from the University of Florida, Jacksonville. They couldn't be here today, but they contributed a lot to this book, and so I'm very indebted to them for their efforts. So the book that we're celebrating today and launching is titled Animal Experimentation, Working Towards a Paradigm Change. And what an important and exciting time it is to be working on this paradigm change. Recently, we've seen a growing shift in the public sentiment about animal testing. Polling released earlier this year by the Pew Research Center found that 52% of Americans now oppose all tests on animals, which is 2 percentage points higher than what a similar Pew survey found in 2014, and 9 points higher than the results of its 2009 survey. This is the first time that a majority of Americans oppose the use of animal tests. This is an important marker in the many decades-long effort to educate the public about the failed enterprise of animal testing and how animals are used and abused behind closed laboratory doors. While this is a controversial issue that will no doubt face progress and setbacks, I'm privileged to be able to work with colleagues in industry, academia, and governments around the world who are dedicated to making this paradigm shift away from animal experimentation a reality. So biomedical education is one of the fields that's currently undergoing massive global changes with potential to spare countless animals' lives and better prepare the physicians of tomorrow. And this is the area that's the subject of our book chapter. Hands-on skills training in biomedical education has traditionally relied on more than 9 million live vertebrate animals each year just in the US alone. And more animals are used in other countries around the world, ranging from performing minor surgical manipulations to pharmacological interventions to managing major traumatic gunshot wounds, burn injuries, and dismemberments. Based on different factors, including growing concern about the use of animals in invasive and terminal laboratory experiments, technological advances in the medical simulation field, heightened institutional financial constraints, and educators' need for the better teaching and assessment tools, a paradigm shift is now taking place that's seen the replacement of animal use in civilian medical schools and biomedical skills training programs in various countries, along with significant reductions and replacements of animal use in comparable military training drills. So medical students in the US have historically participated in classroom animal laboratories, and this has involved injecting pharmaceuticals into live dogs to observe adverse side effects and performing invasive procedures on live pigs. In physiology labs, students were typically instructed to place catheters into animals' blood vessels, perform various procedures, and then inject the animals with drugs while measuring assorted physiological responses such as blood pressure, heart rate, cardiovascular performance, and things like that. Sometimes students even cut open animals' chests to massage their hearts. Afterwards, the animals were killed. In surgical skills labs, medical students practice incisions, organ identification and removal, suturing, and other basic surgical procedures on live animals. During laparoscopic skills training, students cut open pigs' abdomens and inserted long tubes with endoscopic cameras into the bodies, after which the animals were killed. So at Harvard, where my co-author Dr. John Pawlowski has been on faculty since 1987, he helped end that medical school's controversial physiology lab that involved terminal experiments on dogs. And the university later fully ended its use of animals for the undergraduate medical curriculum in the mid-1990s. Instead of using animals for undergraduate medical training, instructors at Harvard now use academically superior, widely available, and more cost-effective human patient simulators, computer-assisted learning software, and virtual reality programs, which, unlike classroom experiments on animals, accurately model human anatomy and physiology. They're able to create immersive scenarios that mimic real-world medical cases. They allow students the ability to repeat medical procedures until they're proficient. They improve the confidence of doctors in transferring learned skills from the lab to clinical practice. And they also provide educators with real-time performance and objective performance feedback. So fast forward more than 2 decades later to February 2016, here at Johns Hopkins, officials initially defended their use of pigs in a 4-session surgical training course. The university was responding to a nearly 10-year campaign initiated by an organization called the Physicians Committee for Responsible Medicine, or PCRM, which involved letters from physicians and concerned residents, public transit advertisements, petitions from more than 100,000 people, doctor-led demonstrations, and also a Maryland House bill that would have prevented the use of animals in medical training in the state. After acknowledging that Hopkins was among the last 2 medical schools in the entire country that was still using animals for its undergraduate curriculum, Hopkins did an about-face, and just 3 months later, in May 2016, the school announced that it was, they stated that the use of animals, quote, wasn't absolutely necessary, and they also made the switch to simulation-based training. And the next month, the last remaining medical school, which was the University of Tennessee College of Medicine in Chattanooga, confirmed that it was also ending its use of animals to teach surgical skills to students. And with this decision, every medical school in the US has now officially ended animal use for undergraduate medical training, now instead using didactics, task trainers, virtual reality models, cadavers, computer software, high-fidelity patient simulators, and also supervised clinical work. On the international side, animal-free medical education is spreading. In 2011, Canadian medical schools completed the full transition to non-animal undergraduate medical student curricula. And one of the last schools, which was Quebec's University of Sherbrooke, stated about the simulation-based training that, quote, "It's the best way, educationally speaking, to do that type of teaching and learning. For us, it was a no-brainer. The fact that it helped save some animals was a good thing on top of that." The transition of medical education to simulation-based training is also not limited to North America. For decades, the Bachelor of Medicine and Bachelor of Surgery, or MBBS programs at medical colleges in India required students to perform pharmacology and physiology experiments on approximately 1.5 to 2 million animals each year. And this involved things like administering drugs through rabbits' eyes to measure the effects of stimulants and depressants on mice, dissecting live frogs and exposing their hearts to various drugs, isolating guinea pigs' small intestines to observe their response to administered drugs. But in 2012, this all changed. The Medical Council of India, which is the apex medical education regulator in that country, amended its regulations to require the use of computer-assisted learning, or CAL technology, to fully replace animals for physiology and pharmacology training for MBBS curricula. This change followed a directive issued by the then Secretary of the Indian Ministry of Environment and Forests, who instructed, quote, "All of the institutes or establishments associated with teaching of medicine, pharmacy, and other graduate or postgraduate courses in the life sciences to follow the UGC guidelines for discontinuation of dissection and animal experimentation in universities and colleges, and to introduce alternatives to animal experimentation." Similarly, the Pharmacy Council of India and the Dental Council of India also directed an end to animal use for training purposes in their respective disciplines as well. Further, the University Grants Commission in India banned the use of animals for dissection and training purposes, sparing a whopping 19 million animals annually who would otherwise have undergone invasive and terminal procedures in university life science, pharmacy, and zoology courses. These developments in India followed advocacy campaigns led by PETA India, the Mahatma Gandhi Dorenkamp Center for Alternatives to the Use of Animals in Medical Education, or in life science education, People for Animals, politicians, and even a few celebrities. Further, growing evidence has shown that non-animal training methods such as human patient simulation and computer-assisted learning software, they actually teach students anatomy, physiology, and pharmacology, as well as, in some cases better than, animal dissection and experimentation. Another area that's seen a lot of progress in the replacement of animal use is the American College of Surgeons Advanced Trauma Life Support Program, which was introduced in 1978, and it's become the standard of care for the initial assessment and treatment of trauma patients. The course, which involves didactic sessions and skills training, has been taught to more than 1 million physicians and advanced practice healthcare professionals, and is now offered in 86 countries. So historically, the surgical skill station of the ATLS program, which covers invasive procedures such as cricothyrotomy, chest tube insertion, pericardiocentesis, venous cut down, and diagnostic peritoneal lavage, was taught by having students each year practice surgical procedures on the chests, throats, abdomens, limbs of live dogs, pigs, sheep, and goats. However, since the turn of the last century, the efficacy, the practicality, and ethics of using animals for this sort of training has been brought into question due to a whole host of factors. There's been a significant improvements in the technical accuracy and realism of human simulation models. Animals, they found, are unable to properly simulate human emergency clinical conditions. Institutional educational budgets have decreased, yet cost burdens associated with the animal labs are still present. The medical community is focusing more on improving patient safety and reducing clinical errors through simulation-based training, and there's also rising public concern for the treatment of animals in laboratories. So in 1993, the American Medical Students Association, which is the oldest and largest independent association of physicians in training in the United States, adopted an important position statement that, quote, encourages the utilization of non-animal teaching materials and methods in continuing medical education. And this would have covered ATLS training. However, the administrative approval to use non-animal training methods in ATLS didn't come until the year 2001, which is when the American College of Surgeons, which oversees the ATLS program, approved the use of human cadavers in the TraumaMan system as full replacements to the use of animals for ATLS surgical laboratories. The TraumaMan system is made by Simulab Corporation, and it's an anatomically correct human torso with lifelike skin, tissue, organs, and bones, as well as simulating bleeding when cut into, and also an airway response with the ventilator. The American College of Surgeons has also since approved other simulation systems as well, such as SynMan. In 2014, the U.S. Department of Defense issued a memorandum prohibiting the use of animals for ATLS training, among 5 other medical training areas, based on the efficacy of simulation that was available. The DoD's policy announcement was significant because nearly a whole decade earlier, the agency had stated that, quote, all advanced trauma life support training laboratory procedures were performed with animals under general anesthesia, and then they were euthanized. There have been various studies that have shown that TraumaMan performs as well as or better than animal use during ATLS surgical skill laboratories. For example, there was one U.S. military study that compared the self-efficacy of trainees taught emergency medical skills on TraumaMan with those who were taught on live animals, and they found equivalent results in both groups, concluding that, quote, if the goal for trainers is to produce individuals with high self-efficacy, artificial simulation is an adequate modality compared with the historical standard of live animal models. Another study from the University of Toronto found something similar, that training on TraumaMan is superior to animal-based training, and that students and instructors overwhelmingly preferred the simulator model. As a result, the researchers ended the animal use in their ATLS program and stated that, quote, we couldn't justify identifying animals as the only suitable source for providing the necessary training in our ethics application for renewal. So despite all the growing acceptance of non-animal training methods by medical organizations, the use of animals for ATLS training has, until recently, continued to be widespread for many years. In 2007, the Physicians Committee for Responsible Medicine initiated a survey to catalog which ATLS programs across the US and Canada use animals or simulators during their surgical skills laboratory in the course. PCRM had learned from this survey, as well as from research records internally, as well as from whistleblowers, that various facilities use animals in ATLS training. So starting in 2008, PCRM submitted letters to administrators, they filed complaints with regulatory agencies, they held protests calling for transitioning to superior human simulation models, and they even erected billboards as well to draw the public's attention to the use of animals in this training. And due in part to this advocacy effort, and given the numerous studies confirming the efficacy of simulation-based training, today more than 99% of ATLS programs in the US and 100% in Canada now exclusively use TraumaMan and other approved non-animal training methods. But despite the shift from animal use to simulation for ATLS programs in the US and Canada, little was known about the use of animals versus simulation methods in the international trauma training programs. So from 2012 through 2017, PETA and one of my book chapter co-authors, Dr. Marie Crandall from the University of Florida, sent formal surveys via email to officials representing 64 different international ATLS programs regarding their use of animals or simulators as part of the course's surgical skills laboratory. The survey response rate was 87.5%, and we found that numerous international ATLS officials from these countries that use animals for this course wanted to switch to non-animal simulation methods, but they were citing financial constraints as the primary transition barrier. So to solve this issue, PETA established a collaborative program with Trauma Man Manufacturer Simulab and ATLS leaders in 22 countries to cost-effectively replace the use of animals with Trauma Man models. Specifically, as per this agreement, PETA would purchase and donate the Trauma Man models to countries whose ATLS officials agreed in writing to end their use of animals for ATLS training. And as part of this, Simulab also allowed a discount on the replacement skins, which are artificial tissues that cover the Trauma Man model, the throat and abdominal region, as well as a 5-year extended maintenance and support program. So through this program, Trauma Man or ATLS officials now actually spent less per student than they would have spent using animals. And based on the data that was reported by these 22 countries, more than 2,000 dogs, pigs, goats, and sheep were used each year in at least 124 ATLS facilities outside the US and Canada, in at least 373 ATLS courses to teach more than 8,000 surgical trainees. And as a result of participating in this program, these 22 countries represent more than a third of the 64 national ATLS programs that were surveyed outside the US and Canada that have now fully replaced their use of animals for ATLS training. And this was due to a donation that PETA did of 119 Trauma Man models valued at nearly $3 million. So to put all of this numbers into perspective, prior to PETA's Trauma Man donation, 38 of the countries that responded to our survey, or roughly 2/3 of them, confirmed using animals for ATLS training. After PETA's donation, just 14 of these countries, or a quarter, continued to use animals for ATLS training, and a whopping 39 countries, or 75%, surveyed now exclusively use Trauma Man, Sin Man, or other ACS-approved non-animal methods. And so this marks a significant shift in the replacement of animal use for this course globally. Shifting gears a little bit to military medical training, there's been an exponential progress that's been made recently in the replacement of animal use that's been decades in the making. The first published curtailing of the US military's use of dogs, cats, and primates in invasive wound experiments occurred in 1983. That year, PETA publicized plans by the US Department of Defense to shoot live dogs to create life-threatening injuries during so-called wound labs so that military personnel could practice trauma management. Subsequently, the DoD temporarily halted all animal use for this practice before banning the use of cats and dogs and primates. However, there was a caveat that they inserted that the DoD allowed the use of pigs and goats, which continues to this day, in a practice called live tissue training. And this is a practice that thousands of physicians, veterans, and even the New York Times editorial board have come out against. The DoD's present-day incarnation of live tissue training involves instructors attempting to mimic human combat injuries by inflicting damage in thousands of live pigs and goats each year. This includes gunshot wounds, limb fractures, propane torch burns, laceration, and hemorrhage, so that students can attempt to identify the injury and then practice the treatment procedure. Trauma training, although not necessarily with a live tissue training component, is a pre-deployment requirement for many military medical providers and even some non-medical personnel through the DoD and other federal agencies. A US military study actually criticized the use of animals for hemorrhage control training, stating that, quote, problems with this type of training model are multiple and include differences in anatomy, differences in the force required on the tourniquet to arrest bleeding, ethical concerns for the animals, and lack of repeatable training, as erroneous management frequently results in the death of an animal. Unlike using animals, strikingly realistic simulators such as Simulab's Trauma Man system, Strategic Operations Cutsuit, CAE Healthcare Caesar model, K-Force Government Solutions Multiple Amputation Trauma Trainer, and Laerdal's military mannequins, among others, faithfully replicate human anatomy and physiology, and they can replace live animal trauma training in full. Indeed, PETA and some medical experts actually published a study that was published in the journal Military Medicine, found that 22 out of 28 NATO countries have reported that they avoid animal use in their military medical training. Instead, they use human patient simulators and other non-animal training methods. Following decades of innovations in the medical simulation industry to create lifelike human trauma models, protests by animal protection organizations, and decreasing public acceptance of the use of animals in laboratory experiments, and increased congressional pressure to end live tissue training, the U.S. military actually launched a multi-million-dollar combat casualty training consortium program in 2010 to investigate alternatives to the use of animals for military medical training. One consortium study presented at the 2014 Military Health Symposium and commissioned and funded by the DoD found that Army medics who were taught hemorrhage control and other emergency medical procedures on human simulators are as proficient as those taught using animals, and that both methods produce similar degrees of stress in trainees. The study also found that a simulator training would be more cost-effective than live tissue training, and that the Army could save in one course alone over $1 million by replacing animal use with trauma training using simulators. In 2014, there was a surgeon in the U.S. Air Force who summarized the state of simulation technology for emergency medical training, writing that in the journal Military Medicine, we have entered into an age where artificial simulator models are at least equivalent to, if not superior to, animal models. The military should make the move away from all animal simulation when effective equivalent artificial simulators exist for a specific task. For emergency procedures, this day has arrived. Similarly, in 2014, NATO's Science and Technology Organization launched a task group to evaluate suitable non-animal training methods to replace animal use in live tissue training, noting that, quote, the use of animals for live tissue training has come under significant scrutiny in many NATO nations, to the point where the use of animals for military medical training will have to be severely curtailed, if not completely eliminated. But despite all of this evidence on the viability of human simulation models to replace the use of animals for this sort of training, nothing moved the needle forward more for animals than disturbing videos showing how animals are used in these courses are abused. In April 2012, PETA released an eyewitness investigation of a Coast Guard trauma training drill. In this video, instructors cut off inadequately sedated goats' legs with tree trimmers, they sliced into their abdomens to pull out their organs, and they stabbed them with scalpels as they moaned and kicked. In 2015, PETA released another eyewitness investigation, this time of Deployment Medicine International, which until recently was the self-proclaimed largest trainer of U.S. military forces in operational medicine. This video footage captured in North Carolina shows live pigs who had been shot in the face and instructors cutting into the animals to induce bleeding, as well as making various racist, sexual, and homophobic remarks. These investigations, along with numerous protests, complaints filed with government agencies, and even a congressional inquiry, helped prompt several key policy changes regarding medical training in the military. So, for example, in 2013, the U.S. Army required all non-medical personnel and certain medical personnel to exclusively use human simulation training methods instead of live tissue training. In 2014, the U.S. Coast Guard cut its use of animals for live tissue training by more than half after meeting with PETA. Also in 2014, the DoD directed all military service branches to stop using animals for 6 areas of medical education, and these areas included advanced trauma life support, obstetrics and gynecology residency training, pediatric intubation training, and certain types of trauma training, among other areas. In 2017, something exciting happened. Then Commandant of the Coast Guard, Admiral Paul Zunkoff, told members of Congress that the Coast Guard was suspending live tissue training for at least 6 months to examine alternatives, and indicated that the choice was more ethical than practical. In a hearing before the House Appropriations Committee regarding this live tissue training, he told one of the members of Congress, quote, like you, I found that quite honestly abhorrent in terms of meeting our mission requirements, end quote. After completing this review and after receiving a bipartisan letter from dozens of members of Congress reinforcing the need to make this ban on live tissue training permanent, in 2017, the Coast Guard made history by becoming the first branch of the U.S. military to fully end all use of animals in live tissue training in favor of simulation models. And earlier this year, in 2018, the President of the U.S. Signed the bipartisan John McCain National Defense Authorization Act, which included a first-of-its-kind restriction that required the agency to use medical simulation technology in trauma skills training to the maximum extent practicable before harming any animals. Medical experts and animal advocates have also raised concerns about the use of animals in the military's chemical casualty training program following the release by PCRM of a video in 2009 showing a monkey who was enduring a simulated nerve agent attack during such a course for the U.S. Army. The agency at first defended its use of animals as, quote, the best model for simulating a cholinergic crisis in humans, end quote, despite published studies showing that the ability of human simulators to effectively approximate the signs and symptoms of a chemical weapon attack and accurately represent human anatomy. Yet in 2011, following public protests, congressional inquiries, and many, many, many letters to military officials by animal advocates, the Army announced that it would replace its use of animals for this training with trained actors, computer programs, and high-tech human-patient simulators. In effect, the animals were replaced with more anatomically correct and physiologically relevant human simulation models, which establish a credible gravity to the educational experience. According to documents obtained by PETA via the Freedom of Information Act from 2010 through 2014, military physicians, pediatric residents, nurses, and medical technicians traditionally learn neonatal intubation by forcing hard plastic tubes down the throats of ferrets and cats, delicate airways, as many as 10 times per animal each session. This procedure can cause bleeding, swelling, pain, scarring, and collapsed lung, and sometimes even lead to death. Following numerous letters to the leadership of various military installations by concerned members of the public and military physicians, each facility ended its use of animals for pediatric intubation training. And as I said before, a full ban on this use of animals was achieved in 2015. So there's a whole body of simulation, or whole body simulation and task trainer devices are frequently used as educational tools in place of animals. Implicit in the replacement of animal use is that the simulation-based methods have equal or better pedagogical outcomes for the learners, and several studies confirm this point. There are actually 6 key advantages to using human simulation models instead of animals. First, high-fidelity simulators accurately model human patients. They can adapt to medications with changes in heart rate, blood pressure, and respiratory rate. They can demonstrate a number of pathophysiological disease states. They can teach surgical procedures that mimic surgical anatomy, duplicate bleeding vessels, and features flaming cautery to coagulate hemorrhage. They can also measure the reduction in time to perform the task as a measure of proficiency. They can record surgical errors, and they can be accompanied by real-time feedback in a deliberate practice. Second, simulators improve the technical proficiency. In one randomized study that looked at emergency procedures, researchers assigned subjects to either human simulator or live animal training labs, and the results demonstrated that trainees had significantly better acquisition of procedural skills when the simulators were used. Most of the perceived benefit came from human anatomic features that were used in the simulators. Third, simulators improve patient and medical provider safety. All simulation training avoids the potential risk to the patient of medical training-induced complications. The first needle insertion or suture repair or incision by a medical student can be done using a simulator. Also, the use of simulation can prove to be safer for the medical student themselves by avoiding any transfer of disease when doing needle punctures. Fourth, simulators foster development of higher-order cognitive skills. One study examined the use of high-fidelity patient simulation on various types of learning that medical students report following a simulation-based exercise. Aside from simulators' learning by doing paradigm that fosters technical skills development, 46% of students felt that simulators are superior to other methods in teaching clinical decision-making and communication and teamwork. And fifth, students benefit from immersive simulation-based training that mimics realistic clinical scenarios. So surgical equipment, anesthesia machines, gowns, gloves can all bring the learner into an engaging and realistic immersive clinical space. The level of engagement has been well documented, and such levels of activation are crucial to learning and the promotion of key non-technical skills like effective communication, an organized approach, management of resources and people, and maintenance of global awareness. And lastly, simulation shortens the medical training learning curve. There was a meta-analysis that was found that the majority of reports demonstrate the utility of simulation in providing faster learning with better retention of concepts over time. So the choice of which medical training modalities to use should be based, in my opinion, on key metrics, such as what method improves provider knowledge, confidence, proficiency, and accuracy. For all of these criteria, there are studies that have confirmed that providers trained via human simulation meet or exceed the standards set by those using live animals. There is a general lack of policy harmonization globally between countries and locally between laboratories regarding the use of animals in biomedical education. For instance, in the United Kingdom, they prohibit the use of animals for surgical training, yet other countries still allow this use of animals for this purpose. The U.S. Coast Guard has banned the use of animals for trauma training drills, yet other U.S. military branches continue to allow this practice. 22 NATO nations, including 19 European member states, have confirmed that they don't use animals for their military medical training, yet 6 NATO nations, some of which are EU member states, still allow animal use for this purpose. And many medical schools around the world continue to use animals for physiology and pharmacology training, among other disciplines, despite this practice having been abandoned by all medical schools in the US, Canada, and India. Concerted efforts, I believe, should be made by institutional animal care and use committees to identify procedures, skills, and concepts that are currently taught at certain facilities using simulation technology and advocate for their adoption by comparable training programs that are still using animals for these lessons. Furthermore, medical education and accrediting bodies, such as the Liaison Committee on Medical Education, the Accreditation Council of Graduate Medical Education, and the Commission on Accreditation for Pre-Hospital Continuing Education, and those comparable international organizations, I feel should publish position statements that reflect best practices for procedural competency, which based on the medical literature would include the replacement of animal use for biomedical skills training. Although postgraduate pharmacology and physiology courses, as well as graduate medical residency programs, such as surgery and emergency medicine, largely continue to use animals in procedural skills exercises, there are discrepancies that still exist today between certain residency programs that use animals in skills training and other residency programs that don't use animals and instead use simulation-based training. In an effort to optimize student learning to minimize and replace animal use in classroom experiments, I would recommend that the ACGME, or the Accreditation Council of Graduate Medical Education, formally and regularly review new simulation technologies and residency curricula of member institutions across various pedagogical and outcome metrics to determine if the replacement of animal use in residency training can achieve standardization across the board. And lastly, I'll leave you with this. For teaching similar medical skills and concepts, there really should be no excuse for an animal suffering in one laboratory and another institution being able to provide the same teaching standard, but using simulation models. Institutions have a responsibility to replace animal use when possible, and PETA and others are now expanding efforts to ensure that global biomedical education of the future is animal-free, incentivizing institutions to move in this direction through public education, eyewitness investigations, advocacy campaigns, regulatory complaints, public protests, and media coverage, as well as partnerships with medical simulation companies to donate advanced simulation technology to replace animal use. Thank you very much.
So for the simulation models, do you know if there are a variety of model that is representative of human population in terms of gender, age, ethnic background being used?
Yeah, so there are adult human patient simulators as well as pediatric or neonatal models. And there's also, especially in the military, they just debuted a female-centered model as well, specifically for gynecology and obstetrics evaluations, but also for trauma as well. Mm-hmm.
Thank you very much for this very comprehensive overview about your activities. And I think it shows very nicely that there's a lot of overlap in goals, while your tools are obviously very different to what an academic center can actually do. And I would like to take two of your examples to show where we are actually synergizing on these type of things. You mentioned the case of pig use here in the School of Medicine. Mm-hmm. After the pressure which was built up by PETA, the surgeons over there came together with us in 3 meetings and 1 symposium where we brought in people to show technologies which can actually substitute for these type of things. Yeah? So it is really opening up for discussions which they would not have with you, but they have them with their scientific colleagues, bringing in academics, demonstrating how other universities have solved this problem. Another example is this very dramatic ban of dissection in India. an instrumental factor to this was that we created via the Dernkamp-Zbinden Foundation, where I'm vice president, a chair in India, the Mahatma Gandhi Dernkamp Center you mentioned, with a chair, Mohammed Akbar Shah, who was instrumental in getting this done, because you need an internal champion. You cannot come as a European or American to India and say, you should do this or you should do that. You need to build up the champions which are then executing these type of things. And again, here I think the synergy of public pressure, awareness, and sound scientific advice from an academic center was a perfect mix. Yeah.
I completely agree. And there's also another example with the military medical training. I went to a symposium recently for a military research symposium, and one of the people I spoke with was conducting a comparative study of live tissue training versus simulation, and he privately told me, like, thank you, Peter, for the public awareness that you brought to this issue, because without this, there would be no funding from the government to want to fund this initiative. So once the public awareness is brought there, then the government steps in to fund projects, and then the scientists can then take over to do their important work as well.
Thank you, Shane.
Thank you.
Okay, the next speaker will be Adam C. He is a doctoral candidate in philosophy at the City University of New York and an adjunct professor of environmental ethics at the New Jersey Institute of Technology. And I think he's finishing next month his PhD. Wasn't that the plan? Oh, it was postponed. Okay, okay, sorry about that. So yeah. And his work, his written work, focuses on the contemporary intersection between animal ethics and animal cognition, as well as communication and collaboration in great apes. And he also focuses on issues around animal experimentation. Please welcome Adam.
That's okay, I got it.
Okay, good.
Yeah. Where's the mouse? Yeah, I don't. Does the mouse not work on this? Oh, it's over here. Ah, I see. Okay. Look at that. Now I put it over here, like so. And oh, come on. There we go. Good. Okay. So let me just see if this. Yes, and it works. Good. Okay. So hi, my name is Adam, and first of all, thanks to Kat and for Kim for inviting me to be here. As Kat said, I'm a doctoral candidate in the philosophy of animal cognition and also comparative psychology at the City University of New York. My central area of research right now is the long-running question as to whether there is some cognitive capacity or set of capacities that makes the human mind fundamentally different from or exceptional to the minds of other species. The list of potential candidates for uniquely human capacities is quite large and can be traced back to antiquity. Language, collaboration, moral agency, numerical ability, metacognition, theory of mind, culture, and particular emotions such as grief. So as is the norm in the animal minds literature, I'm largely interested in these questions for their own sake, because the similarities and differences between human and animal minds are really fascinating. However, I'm also deeply invested in animal ethics and in research ethics, as Kat said. So years ago, when I first started thinking about my dissertation on human exceptionalism in mental faculties, I ran into a moral quandary that, to my surprise, very few ethicists had written about, namely that the majority of behavioral research on the aforementioned topics is conducted on animals bred into lives of captivity. The reasons for this are clear enough, the most obvious being the degree of experimental control that's simply unavailable in the field. As with most ethicists, I had strong opinions on animal experimentation, but they were isolated to biomedical experimentation. Behavioral research, I discovered, largely received a free pass, both by philosophers and by governments. So, for instance, despite biomedical research on great apes being mostly banned in the EU and in the United States, where chimpanzees have recently gained endangered species status, thankfully, so-called non-invasive or behavioral research on great apes, and especially other primates, continues largely untouched in these countries. Behavioral research is not easy to define. It can range from purely observational research in the field to controlled experimental trials in captive environments involving touchscreens, non-invasive neural imaging, and competitive and collaborative activities with humans and conspecifics. So years ago, when I originally started to look into where the primate studies that I was citing were undertaken, I came across the myriad of ethics violations of the now infamous New Iberia Research Facility in Louisiana, where Daniel Povinelli and colleagues were publishing their popular experiments on chimpanzee theory of mind. In short, the sordid conditions at New Iberia culminated in a 108-page complaint by the USDA, ultimately leading to the retirement of 220 chimpanzees to sanctuary in 2016. Other popular research centers, including the Yerkes facility, have faced similar ethics violations by the Humane Society of the US. But specific examples aside, as a philosopher, I began to think more broadly about behavioral research on captive animals. Namely, it's relatively easy to point to egregious cases, but the key question is, the question that really is, I think, central, is what does morally justified behavioral research on captive animals look like? Does it exist? Which is a really hard question, since it doesn't necessarily matter whether the institution in question has faced official ethics violations. Breeding animals into captivity to satisfy questions of pure scientific curiosity, for instance, is numerical ability in birds, might reasonably be considered morally problematic in and of itself. So given that captivity in any context necessarily brings with it ethical concerns, behavioral research on captive animals should hardly be exempt, from field stations to sanctuaries to zoo colonies with conservation programs and to research facilities, which I define largely as laboratories with naturalistic and or enriched environments, such as Yerkes. But the range of potential, let me see if I'm on the right one here. Ooh, it's not. There we go. Yeah, there's Yerkes. But the range of potential topics of interest here is immense. And in this short talk, I'll be focusing exclusively on primates in research centers. Obviously, lots of behavioral research is also conducted in zoos and field stations, et cetera, and in the wild, but I just lack the time to talk about the moral intricacies of those cases. I do recommend, for those interested in looking at the ethics of research in the wild, Laurie Gruen and Kristen Andrews from York University have written excellent papers on this. So let me just, oh, not there yet. Okay, good. So to be crystal clear, I'm working with like 2 space bars here. To be crystal clear, the aim of this talk obviously is not to criticize any particular researcher or research program or institution. My focus is strictly on the moral justification for performing this type of research in the first place, particularly insofar as it entails breeding programs. Right? That's central. And maintaining captive animals in non-sanctuary environments to satisfy pure scientific curiosity. So, there we go. Sarah Shuttleworth highlights 2 motivations for studying the animal mind. First, there are various practical considerations, of course, for addressing issues in conservation and animal welfare, such as whether certain types of fish or insects feel pain, for instance, as well as the construction of animal models for applications in various fields. And then there's the second, quote, equally important motivation, which is sheer scientific curiosity. And indeed, much of the animal minds literature tacitly operates under the banner of so-called pure science, science without any clear or direct practical implications. It addresses Darwin's age-old question as to whether the difference between the human and animal mind is one of degree or kind. Daniel Povinelli's work on chimpanzee folk physics offers a prime example of this. Based on a series of experiments, Povinelli argues that chimps understand the physical properties of objects in a way that's fundamentally different from humans. Just a brief note on this, few today actually accept that conclusion, myself included, and one reason for this was given by the great cognitive ethologist Colin Allen, who notes of Povinelli's work that the stark and austere conditions at New Iberia may have introduced confounding valuables. So, in this talk, I argue that the second class of behavioral research, henceforth referred to as sheer scientific-based behavioral research, or just SC research, nice and easy, presents an ethical challenge that's not faced by more commonly discussed forms of animal experimentation. SC research can be defined as experimental or purely observational behavioral research with no expected or foreseeable practical consequences. I'm focusing here on experimental. The motivations of the researchers are essential to this definition, namely those with the basic desire to know for the sake of knowing, not to mention, of course, academic eminence, research grants, the desire to publish, and so forth. So, introduce a moral challenge. Practically all discussions of the ethics of animal experimentation involve some form of utilitarian calculus, namely one that tries to weigh the beneficial consequences of experimentation with the costs associated with it. You all know this. Utilitarianism, frankly, is not my preferred moral framework, but for obvious reasons, it's ubiquitous in research ethics. The challenge that I pose to pure research facilities that breed and maintain animals to satisfy scientific curiosity is that such practices are incredibly difficult to justify on utilitarian or consequentialist grounds. There's even a crucial sense in which, given a utilitarian calculus, breeding and maintaining animals in captivity for the sole purpose of scratching an intellectual itch is actually more difficult to justify with reasoned arguments than are invasive biomedical experiments. Invasive biomedical research clearly evokes more welfare concerns than behavioral research, but the welfare concerns in the former can be, and often are, argued away on the basis of some anticipated practical benefit. SC research, on the other hand, may be legitimately said to evoke fewer welfare concerns. I mean, that's just obvious. But without any expected or foreseeable practical benefit to fall back on, convincing justification for breeding and maintaining, for instance, primates in captivity rather than placing extant primates in sanctuary, like the 220 New Iberia chimps, is by no means obvious. While those who conduct SC research in zoos are capable of offering additional justifications for captivity, perhaps the conservation efforts of their host institutions, perhaps endangered species status, perhaps just the fact that they're already there, it's very difficult to make a case that continued breeding and maintaining of animals at pure research facilities is morally justified. So I'll show that with this. So here's a moral principle. Hopefully this will be uncontroversial to you, and if not, I'd like to talk after about it. Interest motivated by the desire to satisfy intellectual curiosity with no foreseeable practical benefit should not compromise or outweigh the welfare interests of others, because the former type of interests are comparably trivial relative to the latter. Species is, the principle is non-speciesist, right? It applies to research on humans, as well as any sentient being capable of having interests in the first place. And importantly, and this is probably the most important point, it doesn't make all SC research on captive animals unethical, right? It's not like this principle says that every single study that's ever been done with chimps and touchscreens is wrong. So for many animals raised in captivity, for instance, removing them from their long-time environment or colony would not be in their interests, nor would especially releasing them into the wild, which would be a recipe for increased suffering or death. As such, many animals already in social groups at zoos with conservation and or welfare-directed mission statements, this principle might readily promote their continued existence in these environments alongside other welfare interests of the specific primate populations in question. So here's an example. The Wolfgang Kohler Research Center website claims that the breeding program at the Leipzig Zoo, where many of their primates live, is framed within the global strategy of the European Endangered Species Program. Some research focuses on the husbandry and care of great apes in captivity. Now, programs of this sort maybe tilt the scale in favor of moral justification for continued SC research at these institutions, so long as the experiments themselves, of course, can convincingly be argued to not compromise the welfare of their test subjects already there, such as so-called voluntary participation of apes in experimental games that are quite popular in the literature. I'm personally not convinced that such programs justify breeding apes into captivity, but I'm very open to discussion on that. So the principle, our principle simply states that X's interests in bodily mobility, choice of social and sexual relations, general psychological well-being, and so forth, always outweigh Y's interests in satisfying her intellectual curiosity. It therefore follows that whenever X's interests and Y's interests are at odds, it's Y's obligation to explain why her interests to conduct SC research are not trivial when compared to X's welfare interests, or that Y's intellectual interests do not actually supersede X's welfare interests, as researchers in zoos, or especially in the wild, may claim. Research centers, on the other hand, are very unlikely, I'd argue, to satisfy this principle. So that said, what's most important here is not this principle itself, or others like it. I just made that up. The principle is just a tool. A general principle like this is intended to open up conversations about the ethics of particular cases, and as the majority of research in comparative cognition is conducted on captive animals, these conversations should be far-reaching, and that's the extent of my positive claims here today. So I'll turn to a few counter-arguments. So to begin, some might take issue with my liberal use of the word practical and suggest rightly that while it may be true that individual researchers take themselves to be scratching an intellectual itch, the scientific enterprise as a collective effort almost always bears practical fruit, even from the most obscure research programs. So if that's true, then the utilitarian calculus suggested here starts to look a hell of a lot more complicated, since it requires the estimation of possible future utility of discoveries arising from research programs that, when undertaken, do not seem to have any practical value at all. My general response is as follows. When defining the parameters of SC research, I stress the importance of researcher motivations, because almost any, maybe not almost any pure research could be justified on the basis of ad hoc practical applications. But consider research on whether theory of mind is uniquely human. In short, to have a theory of mind means that you perceive other beings as subjects with mental states like beliefs and desires, rather than just as readers of behavior. Thanks to SC behavioral research, there currently exists strong evidence that, in addition to humans, great apes, elephants, cetacea, and maybe magpies, oddly enough, have a theory of mind, but no other species so far, to my knowledge, maybe a few others have, like dogs, for instance, don't have a theory of mind, it seems. Monkey species, I think there's one study that's shown that monkey species, I think capuchins have a theory of mind. But it's largely taken, or it has been taken at least since the early 2000s, to be a uniquely human capacity, but that changed because of behavioral research. So one foreseeable challenge, and I think it's the best challenge to what I've been saying here, is that work on theory of mind in captive chimpanzees does clearly have practical repercussions, in the sense that this debate has been, well, I mean, Robert Lurs, who's a animal minds philosopher at Brooklyn College, says that the theory of mind debate has been central to personhood debates. I'm not sure if that's true, but it's important to them for sure. So one might say then, with respect to theory of mind research, that chimpanzees bred and maintained in naturalistic research facilities are in some sense martyrs for scientific knowledge that may foreseeably have practical applications regarding the welfare of their entire species. So despite it being the case that animal minds research is frequently used in the animal ethics literature, this potential response is unappealing to me. It would be far more difficult to make this sort of argument, for instance, with capacities like numerical ability or shared intentionality or culture, well, maybe not culture, but definitely numerical ability, shared intentionality, where moral relevancy is unclear. A lot of those uniquely human capacities that I mentioned earlier would fall into the, well, what does that matter about, above and beyond the fact that, these animals are sentient and have, complex mental lives. But as I mentioned, I mean, there seem to be some capacities, perhaps theory of mind, certainly memory, definitely memory, where it's arguable that behavioral research on captive animals has been important to convince authorities that animals deserve moral consideration. Sentience alone just doesn't carry the pragmatic weight that cognitive capacities often add to these debates. That's true. So I don't have a clear answer for this counterargument, really. I mean, I'm not sure there is one, apart from encouraging more creative behavioral research on wild animals, which of course carries its own methodological and ethical concerns. The animal ethics literature and the legal battle for animal rights certainly does borrow heavily from the animal cognition literature, but it's important to point out that one can grant that the long-running research program in theory of mind has benefited the welfare of great apes, for instance, while still arguing that future SC research is morally unjustified. It's also worth noting, and this should be obvious, I think, to all of you here, that research in captive environments can induce confounding variables into animal minds research, as captive and wild animals very often exhibit disparate behaviors. That's Kimberly Jane's half of our chapter. One example that I quite like of this is in 2006, I believe, one of Povinelli's collaborators, Joan Silk, and colleagues published a paper arguing that extended altruism, namely helping others outside of your group or family, is uniquely human. And they found this by, I'm not going to get into the test itself, but it was a test on captive chimps, and involving some cages and some buttons and some giving food to strangers versus group mates and kin, and that conclusion that extended altruism is uniquely human was pretty popular. I mean, that's a really cited paper. But then in 2010 or 2011, Christoph Burch and others released a number of papers about chimpanzee groups adopting conspecifics from other groups, which seems to falsify or at least cast serious shade on Silk's groups. So, I mean, that's certainly a related topic and one that I'm very interested in. I'd recommend that you check out Kim's section of the paper for that. Okay, just finishing up. Another foreseeable counterargument would just evoke the naturalistic or enriched conditions provided by research centers such as Yerkes. Many research centers are partnered up with local zoos, such as the Rolling Hills Refuge Conservation Center, pictured here. I'm categorically opposed to zoos, and I readily grant that zoos and research centers exist on the same moral spectrum. I also readily admit that sanctuaries belong on this spectrum as well, insofar as the subjects from sanctuary research are more often than not subjects to past trauma. Though, I mean, these environments typically fare much better than the naturalistic conditions found at research centers, obviously. So, in short, naturalistic confinement conditions are not strong enough justifications to breed non-human primates and other animals into captivity for sheer scientific curiosity. However, as noted above, this does not mean that animals already in naturalistic conditions should necessarily be moved. Okay, so in the absence of any clear benefits for the animals themselves, it's evident that SC research conducted at pure research centers cannot readily satisfy, one, the self-evident moral principle that I provided, or two, any given utilitarian calculus that one might apply to justify this particular kind of research. And it's important to keep in mind that behavioral research is primarily conducted on animals in captivity. More importantly, very few ethicists focus on it, and that these sorts of breeding programs will continue until the discussions of the ethics of animal experimentation are conscientiously expanded to include behavioral research beyond the parameters of just biomedical research. Thanks. Sure.
Did you mention anything about the ethics of zoos?
No, I didn't. I didn't.
Would you care to comment on
Yeah, I mean, my comment might not be terribly satisfying. I feel that to be born into a life of captivity, it's better not to be born at all. I believe that. So my basic, perhaps unsatisfactory response to your question would simply be to evoke that adage or whatever, you know. And then I mean, a lot of the animal minds research is conducted at zoos, like I mentioned earlier. And I mean, even in those cases, I mean, the animals are already there, but the zoo research doesn't always match up with findings from the wild. And I mean, herein lies the major methodological issue in animal cognition. You have findings from the wild, which suffer from issues of epistemic and methodological control, but that are more ethical. And then you have, right, on the other spectrum, you have studies on captive animals, you know, where controlled conditions are possible, such as Franz de Waal's work in, is it? Yerkes, yeah. Is possible, but in those conditions, I mean, I'm sure if de Waal was here, he'd disagree with me on this, but, you know, apes in those conditions don't always act in the same way as apes in wild conditions, so, yeah. Yes?
Hi.
Oh, sorry.
This is more of a philosophical question. I'm not sure how to pose this. So from a scientific or a philosophical point of view, do you think we could develop a spectrum from useless to somewhat useful to useful experiments of this nature, and then try to figure out a way collectively from a scientific community and from the general society to get rid of some of these experiments that we think are useless? So one of the examples that come to mind is that institution in New York, where this was the subject of the Non-Human Primates Project, where they were using some chimpanzees to look at the origins of bipedalism. Mm-hmm. Do you think that sort of experiments are necessary nowadays? We've been bipedal for at least 3.2 million years. If you look at Lucy, right? So should we even be, as taxpayers, funding that kind of thing?
No, no, I don't think so.
Obviously, the answer is no. But how do we get rid of things like that? Do you have any creative ideas?
I think my best answer for that question would be to expand, like I mentioned at the very end of my talk, expand the parameters of the ethics of animal experimentation to include behavioral research. There are very, very few papers on, I don't say that my paper on this subject is like amazing or anything like that, but it's one of the only papers that's been published or that will be published on this subject. So we need more people talking about behavioral research as actually entailing moral issues, right? I mean, it seems sort of widely thought that as long as the experiment is non-invasive, as long as the animals say was already there, then, you know, who cares, right? But that totally ignores the fact that these animals are living their lives in captivity. Why? Simply to scratch an intellectual itch, mostly. In terms of a spectrum, I would say that could actually be, I haven't really thought of that, but that could be fairly easy, I think, to construct. What you'd do is you'd look up criteria that's convincing for personhood. And like, for instance, Marianne Warren talks about how metacognition, in her criteria, is essential to be a person. I disagree with that, but that would make it such that metacognition is maybe a justifiable form of SC behavioral research. I don't think anyone would say, for instance, that numerical ability is necessary to be a person, so that would pretty much cancel out all of those experiments, right? Although it is cool to know what species can count or not, or if they can add things together, but, you know, hope that helps. Yeah.
Just two quick comments. The first is, I know that thank you for the presentation.
Oh, yeah, thanks.
And interesting. Thank you. Oh, thank you. I know that your work that you're presenting today is primate focused, but I just want to point out that this issue of altruism, I think many people in this room may know that out of the University of Chicago, Peggy Mason and her colleagues did some work showing that rats would express altruism toward other rats who they didn't know, whom they didn't know. So, there does seem to be a lot of evidence with other species, non-primates, who show altruism.
Right.
So that's my first quick little point, just comment. And the second one is I was really intrigued by your comments regarding martyrdom and animals who are martyrs so that we can have empathy for them and perhaps treat them a little bit better. And that's intriguing to me because, I read Peter Singer, and of course, Thomas Hartung referenced Peter Singer, and it's mentioned in the book. He does something in the book, preface or something. But Singer, of course, said that sentience was enough. If animals are, if a being is sentient, then that should be enough to extend consideration to that being as a moral agent to whom we, extend consideration and don't exploit.
Right.
And now it seems theory of mind is going to be, the whatever.
Right.
The hill on which we die. Determined. But this is weird to me that it's human inability to understand others or have empathy for others who don't look like us or are not familiar to us. And somehow animals are constantly having to, come up and pass a test, and that just seems wrong.
Yeah. Thank you for your comments. Regarding the second one, my dissertation is actually it traces the history of studying the history of human exceptionalism in studying the animal mind from antiquity to the current day. So I identify common strategies that were used by Aristotle, Descartes, and people like Michael Tomasello and Daniel Povinelli alike, right, to demonstrate that this particular capacity is uniquely human or exceptionally human, and it has no place whatsoever in other species. One of those strategies is moving the goalposts, right? So it's like whenever let's say we define language as X, and then as soon as it's found out that some species can do X, we're like, well, no, it's not quite X. Actually, they have to have syntax too. And then it's like, well, okay, so maybe there's a little bit of syntax there, so now it's this. That strategy has been used for pretty much every single uniqueness claim that's ever existed. And it's telling with respect to your comment that it seems like, at least in the higher levels of academia and medicine, people are very reluctant to say that, animals, are metacognitive, for instance, right? It seems like humans always have to be exceptional in some way, right? So, I mean, in this sense, this kind of behavioral research can be helpful because it can break down those uniqueness claims and exceptionalism claims. But at the same time, just to comment very shortly on your first question or on your first comment, it's not necessary. Frankly, knowing that a chimpanzee has a theory of mind means that the chimpanzee has a higher capacity for psychological suffering, perhaps. But I don't see how that really matters a hell of a lot, frankly, because we wouldn't treat a chimpanzee any different, or I wouldn't anyway, than I would a monkey, right, or a dog or a pig. So I'm with you on the sentience criterion, but in terms of, a more cognitive criteria, I understand the impetus for that too. Yeah.
Any more questions? Or are you all ready for lunch? Okay, Adam, thank you so much.
Thanks,
that
Kat.
was wonderful.